Night gathers across a turning planet, and the sky lifts like a slow curtain. He watches the first points appear, simple as pinpricks, patient as breath. Then, a deeper darkness follows, not emptiness, but a stage where forms sleep. Somewhere within that velvet, a spiral writes itself with light. Somewhere else, a faint oval glows with calm resolve. The eye searches and finds rhythm where there should be only noise. The heart settles, as if hearing a pulse that does not belong to blood, but to a larger quiet. A galaxy is a pact between motion and memory. Every star carries momentum it refuses to surrender. Every cloud of gas remembers gravity, even when turbulence tries to make it forget. The result is neither chaos nor stasis. It is a poised turning, a dance that keeps its shape, like a flock that becomes a living geometry. He wonders how such serenity can rise from ingredients that prefer to collide, shatter, or burn. He imagines a sea without shore, and in that sea a whirlpool that remains circular, even as each drop races through it. Pattern survives the passing of its parts. The arms of a spiral do not trap the stars they hold. The bar at a center does not freeze the flow it guides. The ellipse of a halo does not stop time. Yet the design persists, and the mind relaxes because it sees something that repeats. Everything, it seems, conspires to reassure. The disk spreads thin, but not too thin. The bulge swells, but not too far. The dark halo waits, a cushion beyond sight, steady as a hand beneath porcelain. The balance is never perfect, and never finished, which is why it feels alive. A galaxy does not promise safety, only coherence. Supernovae spark like sudden cymbals, but the melody continues. Jets slice the interstellar night, but the chorus does not break. Molecular clouds collapse and then dissolve, but the tempo holds. The calm is not the absence of events. It is the presence of rules that soften the shocks. He thinks of time not as a line, but as a tide. Billions of years pass, and yet a spiral arm still curves with a familiar grace that any child can draw with a fingertip on frosted glass. He thinks of space not as a void, but as a studio where gravity is choreographer and friction is editor. The production never closes, and the cast keeps changing, yet the theme remains legible. It is enough to look at one photograph and feel a pulse slow. The mind recognizes a spiral the way it recognizes a face. Symmetry whispers of intention, even when none is needed. Repetition calms the nerves, even when the cycle is born of chance and law. Noise lives inside every process, but noise can be gathered, spread, and averaged. A galaxy is a grand average of many small storms. Turbulence curls within clouds, then dissolves into background. Orbits wobble, then regain a mean path. Encounters tug, but the disk settles. Such things can heal without a healer, not because the cosmos is kind, but because statistics are. He watches a long simulation in his imagination, millions of particles moving like dust motes in a sunbeam. They seem erratic. Then slowly the video reveals a spiral, as if a sculptor were reaching through the data and smoothing it into a familiar curve. There is comfort in that inevitability. There is quiet in the way large numbers erase panic. At the heart of reassurance sits an equation, or perhaps several, but they do not need to be spoken aloud. It is enough to know that gravity is long-reaching, that angular momentum resists haste, that radiation and pressure talk to gas, and that invisible mass steadies a stage we can barely see. These are not lullabies, but they function like lullabies, gentle repetitions that coax a wild infant into sleep. The galaxy is not asleep, however. It is alert, but unafraid. It turns for 100 million years and looks the same after each turn, the way a clock face looks the same each hour, while the hands continue their pilgrimage. The eye finds rest in gradients more than in edges. Galaxies oblige. Brightness sinks from core to circumference with a tenderness that avoids harsh steps. Dust lanes sketch shadows that ask to be traced. Star-forming knots sparkle like dewdrops on a vine. Bars run from nucleus to disk like a bridge in a quiet park at dusk. Even ellipticals, which hide their storms within featureless light, glow with a smooth patience that invites long gazes. He imagines walking their light like a shoreline, never hurried, never startled, only guided by a continuous rise and fall. In that walk he forgets time as measured by appointments and returns to time as measured by cycles. Distance, too, becomes an ally of calm. These shapes are so far that their violence cannot reach. Their light crosses the years as if laid on a stream. When it arrives, it brings no heat, only the information of harmony, as if the universe sent postcards rather than alarms. There is solace in knowing that the cosmos is not a scream, but a composition with rests between its notes. There is kindness in the idea that beauty can survive its own making. Starbirth is noisy where it happens, but the galaxy carries the sound like a cathedral carries a bell. The volume diffuses into architecture. He contemplates a single phrase: quiet geometry in chaos. Quiet, because the mind settles. Geometry, because the eye sees rules. In, because nothing stands apart. Chaos, because the raw materials remain unruly. The phrase is neither paradox nor compromise. It is a description of life at scale. The same can be said of seas, forests, and cities, but galaxies are the cleanest to watch, the most distant from personal stakes. In their remoteness, they acquire the power to soothe. To look at them is to step outside the urgency of the day and into a room where time breathes deeper. The universe did not promise him comfort, yet here it is, written in spirals, ovals, and rings. If he listens, he can almost hear the cadence of long rotations, a bass line under the quick percussion of stars being born and dying. If he looks closely, he can see order emerge from motion without anyone declaring it so. That is the relaxation he seeks, not denial, but comprehension at scale. The idea that patterns can persist even when details change. The idea that a form can be real even when every particle that composes it is temporary. A galaxy is a kindness shown by physics to perception. It offers continuity where the local world often provides interruption. He leans back. The room darkens further. The image on the screen stays. It contains multitudes, but they obey themselves. Somewhere in that order, the mind finds a home, even if it never leaves the chair. Somewhere within the sweep of an arm, the future spins without haste. Somewhere between the bright core and the fading rim, silence draws a line and keeps it. The sky outside the window remains empty to the eye, but he carries the galaxy now, a portable hush, a geometry he can unfold when noise rises. In that act, he joins the slow rotation, and for a long breath, he belongs to it. A winter in Paris, once given to fog, produced a list meant to spare comet hunters confusion. A clerk of the heavens sat at a desk, counted smudges on glass, and gave them numbers. His catalogue would calm the frantic search for new comets by naming the distractions that mimicked them. The man was Charles Messier. He did not know that his modest intent would gather the first quiet gallery of galaxies. His entries recorded blurs that would later resolve into islands of stars. The list offered a meditative cadence. M31, a soft cloud in Andromeda. M51, a faint curl near the tail of the Great Bear. M87, a round glow in Virgo. The ink of that catalogue, dried in the 18th century, still leads telescopes like a whispered itinerary. In England, a family turned a field into an observatory and a furnace into a foundry. William Herschel ground mirrors by hand and built telescopes tall as houses, then mapped the sky with an intensity that frightened sleep. His sister Caroline recorded positions with a precision that felt like music held perfectly on a staff. Together they revealed star clusters and nebulae with a steadiness that rewarded patience. He sketched luminous ovals and irregular patches and speculated that some smudges were not within the Milky Way at all. He traced structure in the night, long before the names for that structure became common speech. Ireland offered a different proof. On a cool night in 1845, the Earl of Rosse leaned into the eyepiece of a metal giant called the Leviathan of Parsonstown. Its 6-foot mirror gathered weak photons and made them legible to the human eye. He drew what he saw. The sketch shows a whirlpool of light with a companion tugging at its edge. He had found in M51 a spiral, a form so simple that any child could copy it, yet so vast that the mind hesitated to measure it. The spiral became a symbol that soothed observers with its familiar curve. The discovery did not draw a headline, it drew a line. Across the Atlantic on Mount Wilson, the dry air of California held steady for long exposures. A new mirror rose on a steel frame like a cathedral rib. The Hooker telescope reached for clarity that had never been possible. A patient man in a suit peered through hours and nights, until the emulsion turned black with the faintest light. Vesto Slipher, using a spectrograph back in Arizona, had already reported that many spirals carried spectral lines shifted to the red. He measured speeds that seemed impossible for objects within a single galaxy. His numbers felt like a warning that distance was being misjudged. Few yet believed that the smudges were separate realms. A debate gathered in an auditorium. On one side stood Harlow Shapley, who had mapped the Milky Way and placed the Sun away from its center, a humbling correction. On the other stood Heber Curtis, who argued that spirals lay outside the Milky Way, grand systems of stars in their own right. The orators spoke with photographs and tables of novae. The audience listened as if a scale were being calibrated. The question was simple: how big is home? The answer waited on a ladder built from a variable star. Henrietta Swan Leavitt worked in quiet rooms filled with glass plates and dust. She measured the pulsing of Cepheid variables in the small Magellanic Cloud and found a relation between period and luminosity. The longer the pulse, the brighter the star. It was a ruler made of rhythm. Her calibration, refined by others, gave astronomers a way to weigh distance with light alone. The method did not shout. It offered a gentle, repeating heartbeat that could be counted and trusted, a music box concealed in a star. Edwin Hubble climbed the mountain and placed that rhythmic ruler against a faint smudge in Andromeda. In 1923, he marked a Cepheid on a plate with a small notation that changed the size of everything. The pulses sang the same song, and the math returned a distance far beyond any reasonable boundary for objects within the Milky Way. The nebula was not a cloud inside a galaxy. It was a galaxy. The calm that followed was not silence but breath released. The sky filled with new addresses for wonder. The numbers implied thousands of separate stellar cities and then millions. A person could look up and feel the mind stretch without tearing. Photography gave the next kindness. Long integrations gathered photons that the eye could never count in a glance. The plates pooled light into arms and cores. The spirals looked stately in black and white. Ellipticals looked like lanterns wrapped in silk. The photographic era invited and rewarded stillness. Exposures that lasted for hours taught observers to respect slow processes. The images that came back from these patient acts suggested a universe laced with order. The arm patterns did not blur into formlessness. Bars crossed discs like deliberate bridges. Rings circled cores with disciplined grace. The telescope became a lesson in temperament. Wait, and form declares itself. Radio antennas then opened a new band of calm. A pair of young experimenters reported a line at 21 centimeters from neutral hydrogen. The wavelength allowed gas across the Milky Way and in other galaxies to be traced without the penalty of dust. The line whispered of cold clouds and large-scale flows. Maps in radio revealed arms wrapped like tapes on a spool. The data built contours of calm structure even where starlight failed. The method felt like touching the skeleton of a living thing without disturbing its skin. Infrared observatories lifted another veil. Dust glowed where stars were forming. The texture of that glow ran along arms and into bars. It showed where gas gathered to become next generations, where warmth pooled in lanes that paralleled dark dust filaments seen in visible light. The infrared images complemented the radio maps like two hands folded together. The results suggested that order persisted across wavelengths, a reassurance that beauty was not a trick of seeing. Orbital mirrors ended the tremor that ground-based telescopes could not avoid. A telescope outside the air returned views as steady as a held breath. Face-on spirals revealed knots and feathers in their arms. Edge-on disks showed thin dust lanes that drew lines as crisp as ink. Ellipticals resolved into swarms of ancient stars and globular clusters that circled like bees around a hive. Structures thought smooth displayed layers. Calm increased because detail increased. The more resolved the view, the more evident the organization. Surveys then accumulated with quiet ambition. Robotic telescopes scanned the same swaths of sky for years and catalogued shapes by the hundreds of thousands. Citizen scientists clicked through images and sorted spirals from ellipticals, barred from unbarred, ringed from plain. A chorus of ordinary eyes produced extraordinary statistics. Patterns emerged in the distribution of types. Spirals favored the field. Ellipticals crowded clusters. bars correlated with mass and gas. The large picture steadied small surprises. At observatories spread across mountaintops, integral field spectrographs broke light across 2 dimensions and tracked the motion of stars and gas within each galaxy. The maps looked like weather charts with zones of flow, rotation curves unfolded along axes, velocity dispersions pooled like quiet pressure systems. The instruments turned color into speed and speed into structure. Observers could watch order and motion share a plane without cancelling each other. Again, the lesson returned. Serenity is not the absence of movement. It is movement held to a plan. A final mile in this phase comes from instruments that listen for the faint murmur of background light. A microwave glow fills the sky with uniformity. On it, small fluctuations planted seeds. Over billions of years, those seeds grew into the filaments and nodes where galaxies collect. Large-scale structure studies found that galaxies arrange themselves along webs that resemble frost on glass. The position of each object is not purely random. Gravity writes in cursive, and galaxies are the letters. To chart them is to read a calm script that stretches across horizons. The story of how the forms were first seen is, at its core, a meditation on patience. Glass plates stored pulses that could be counted. Mirrors gathered light without hurry. Radio dishes and infrared detectors traced cool gas where stars were yet to ignite. Space telescopes removed the trembling breath of air. Surveys replaced anecdote with census. Each tool extended the same courtesy. They allowed order to emerge from faintness. The observer learned to trust that what looks like fog can have a shape, and that shape can carry meaning without chaos being banished. A person with a small telescope and a star chart feels the same relaxation today. The eyepiece frames a spiral in a suburban sky. The light left when ancestors were young. The curve is soft, but it holds. The star chart lists a designation born from someone's careful ink. The object has been visited by minds and mirrors across centuries, yet the image reduces 1,000,000 suns to one gentle arc. That is a kind of mercy. The discovery phase did not merely expand a map. It taught a way of looking that honors slowness and rewards attention. The galaxies did not rush to reveal themselves. They arrived as if walking through a doorway, composed and unafraid. He opens a textbook and finds a simple diagram. A disk rotates, inner parts faster than outer parts. If a spiral pattern were drawn like paint on a record, the shearing would twist it tightly in a short span of cosmic time. Yet the sky shows spirals that keep their open grace across hundreds of millions of years. The first shock arrives as a gentle contradiction. The picture is clear, the logic tidy, the result wrong. Something preserves the curve, something denies the fate of a smear. In a lecture hall, an instructor chalks a rotation curve on a board. According to naive expectation, speeds of stars should drop with distance from the center, the way planets slow as they orbit far from the Sunday. The chalk line instead stays level like a calm horizon. Outer stars circle at nearly the same speed as inner ones. The implication is both quiet and radical. Visible matter is not enough to account for the motion. An invisible mass envelops the disk and steadies it, a cushion that keeps orbits from unraveling and allows the fragile thinness of the disk to persist. The calm image of a spiral now carries an unseen weight, and the mind learns to accept that serenity may rest on hidden scaffolding. Another diagram shows the quick lives of bright stars and the violence of supernovae. Starburst should create its own undoing. Young, massive stars flood their birthplaces with radiation, stir the gas with winds, and end their lives with shocks that rattle the neighborhood. If such storms dominate, star formation would ignite in bursts that tear a galaxy into a restless patchwork. Yet observations reveal global regularities. The rate at which a disk turns gas into stars scales with gas density in a predictable way. It acts like a thermostat that prevents extremes. The surprise is not that feedback happens. The surprise is that feedback, in aggregate, behaves with the restraint of a caretaker. He looks at a list of encounters. Galaxies pass near each other often enough that tides should have left most disks in tatters. The sky should favor wreckage and asymmetry. Thin disks should be rare because minor mergers ought to thicken them like dough folded too many times. Yet thin disks are common, and many encounters end in systems that regain order. Over time, bars grow and then weaken, rings form and fade, but the large-scale calm returns. The shock is not that collisions occur, but that recovery is a built-in tendency. Gravity has a long memory, and the disk finds its plane again. At the center of many galaxies, a black hole with millions or billions of solar masses waits in a volume smaller than a star cluster. Near it, gravity curves space in a way that scrambles orbits and heats gas to extraordinary temperatures. Jets can spear out at high fractions of light speed. The environment seems the opposite of soothing. The shock is that such a furnace can regulate rather than ruin. When the central engine feeds, it can heat surrounding gas enough to prevent it from collapsing into uncontrolled starbursts. When it rests, gas cools and star formation resumes. The cycle produces a measured climate. What looks like a threat becomes a gardener's hand, pruning and allowing renewal. Another quiet astonishment lives in the shapes drawn by magnetic fields. For a long time, magnetism in galaxies was a soft rumor in polarized starlight and radio maps. When measured carefully, the fields often align with spiral arms and guide gas along lanes that feed star-forming regions. They are not strong enough to dictate the orbits of stars, yet they are persistent enough to steer clouds. The idea that a near-invisible field can affect the texture of arms, making dust lanes crisp and flows gentle, adds an unexpected instrument to the orchestra. The shock is subtle. Magnetism does not roar. It threads. He studies stability criteria that predict whether a rotating disk will fragment. A single parameter, a ratio of dispersions and densities, divides order from collapse. If the number drops too low, gravity wins and large regions fall inward. If it rises too high, pressure and shear suppress collapse and the disk becomes sterile. Many disks live near the edge where patterns appear without runaway collapse. The shock is that such a precarious balance is common. The galaxy soothes the eye not because it avoids thresholds but because it hovers near them. Margins become home. On larger scales, the web of structure that cradles galaxies looks intricate yet oddly uniform in its statistics. Clusters gather at nodes. Filaments feed them like nutrients in a river system. The distribution of galaxy types in these environments obeys trends that repeat across space. Spirals prefer solitude or small groups. Ellipticals crowd the densest cities. The shocking part is the regularity of this sociology. It suggests that the serenity of a disk is not only an internal story but also a story of habitat. Where tides are modest and inflow is steady, the disk keeps its composure. Where interactions are frequent and gas supply is harsh, other forms dominate. Pattern is not merely a personal decision of a galaxy, but a community rule. He considers time. Spirals do not belong to a single era. They exist in the nearby universe and at intermediate distances where their light has traveled for billions of years. Even with the changing supply of gas and the growth of halos, they persist as a major population. That persistence under varied conditions is an affront to the expectation that complex structures are fragile. It is as if the cosmos prefers to keep rewriting the same calming poem with new ink. An image of a starburst is placed on the table. The core glows in infrared like a forge. Winds blow outward, carving cones and carrying metals into the halo. The scene promises upheaval, yet the starburst does not consume the galaxy entirely. It eventually subsides, leaving behind a disk that resumes less frantic star formation. The cycle repeats on timescales long compared to human history, but short compared to the age of the universe. The shock is that violence does not escalate without bound. It measures itself, as if the system had a sense of proportion written into its energy budget. A spectrum of a barred galaxy shows gas streaming along the bar toward the center, piling into a ring where orbits switch families. The mechanics are elegant but surprising. A shape made of stars can reshape the fate of gas and set a rhythm for starbirth without needing walls or rails. Gravity alone organizes the flow. The stability of the bar and its coupling to the disk build a slow metronome. The eye sees symmetry. The physics hides a choreography of orbits that weave like braids. A final shock lies in how little detail matters for the grand outcome. Replace one cloud with another, one supernova with a slightly different blast, one minor merger with a mismatch of mass, and the disk still reaches a familiar equilibrium. The sensitivity that plagues weather forecasts does not erase climatic expectation. Galaxies follow climate. Their long-term state is a narrow path through a forest of chance events. The calm face of a spiral is the logo of that path. It is not a fragile masterpiece that shatters if breathed upon. It is a robust attractor in phase space that draws systems toward it. He closes the textbook and looks again at photographs that resolve into arm upon arm. Each shock folds into a broader comfort. Shear that should destroy patterns instead reveals waves that move through stars and gas, carrying compression like a traffic jam that travels along a highway while cars drift through it. Unseen mass supports the disk and stretches the flat reach of rotation. Feedback calms the fever of birth. Encounters bend without breaking. Fields guide without dominating. Stability hovers near a tipping point that yields texture rather than monotony. Environment sets preferences without strangling variety. Time permits cycles to breathe. The mind relaxes not because the universe is simple, but because the complexity cooperates to produce forms that are easy to read. What contradicts expectation at first becomes the source of ease. The spiral does not mean the absence of strain, it means strain contained. The flat rotation curve does not demand panic. It invites the idea of a vast protective halo. The starburst core that blazes does not herald endless fire, it expends itself and leaves room for long seasons. With each surprise, another reason appears for structure to endure. The lesson is not that rule-breaking rules. The lesson is that rules compose, and their composition is more forgiving than a lone equation would suggest. He steps away from the images and feels a curious quiet. The shocks have not shattered confidence, they have rebuilt it with new supports. The galaxy remains what it appears to be, a calm design, but the calm is earned the hard way. The light arrives as a whisper. Inside, the whisper hides a battalion of balances. That is the scientific shock, that peace in a galaxy is an emergent treaty among forces that could, in other contexts, refuse compromise. Here they sign, and the signature is a spiral drawn wide and steady across time. An observatory receives night like a library, accepts readers. Instruments open, the air steadies, and a quiet flow of numbers begins. Each count of a photon lands where theory expects or nudges it aside. Patterns that once felt like impressions become maps. The galaxy on the monitor no longer looks only like a picture. It becomes a field of measured things, each with units, errors, and a place in a larger argument about why shape persists. A radio dish listens for the cold breath of neutral hydrogen at a wavelength that passes dust without complaint. The line is narrow, and its shift reveals motion with a patience that would shame a stopwatch. From center to edge, velocities trace a curve that holds nearly flat over vast radii. Stitched together for many galaxies, these curves form a family portrait that insists on an extended mass beyond the luminous disk. Without seeing the dark halo, the data lets it be handled indirectly. The outer gas does not drift away or slow into a fragile whirl. It circles with the same calm insistence as inner regions. A disk with such support is less easily torn, less easily frightened into chaos by passing tides. Where gas is denser and colder, a millimeter array collects the faint glow of molecules that gather before stars ignite. Carbon monoxide becomes a tracer for molecular hydrogen, which hides from direct detection. Observers convert line intensity into surface density and lay it beside images of newborn stars marked by ultraviolet light and H-alpha emission. Point by point across a disk, the relation between gas and star formation emerges as a slope with scatter but with a real center of gravity. The time required to spend a reservoir of gas at the current pace, the depletion time, becomes a measure of composure. Typical values calm the imagination. Millions of suns combine each year in a large system, but the reservoir would last billions of years. Only in cores where pressures rise does the clock run faster. A blue view from a space telescope, riding above the waver of air, isolates the youngest stars that burn hot and brief. They draw along spiral arms like frost along a wire. Downstream, where gas has been compressed and moved, slightly older stars appear in softer hues. The staggering of stellar ages around an arm, measurable in color and in spectral features, speaks for waves that travel through the disk. The arm is not paint. It is a moving region where density peaks and then relaxes, where clouds fall in and then drift out as they spend their gas. That sequence is a balm to a mind worried about smearing. The structure is not fixed, yet it repeats its logic as tens of thousands of stars graduate from cloud to cluster to dispersal. Spectrographs that spread light across two spatial dimensions treat a galaxy like weather to be charted. Each small area yields a line of sight velocity for stars and for gas. Together, the mosaic draws arrows that curve gracefully around centers, reveal bars in their streaming signatures, and mark rings where orbits switch families. Rings at inner resonances light with star formation, often tight and circular, as if a tide line tracked the boundary between two seas of motion. Further out, another ring may trace corrotation or an outer resonance, a lasso where material lingers longer than elsewhere. These subtle harmonies explain why certain radii host ordered beauty. The disk sings a chord, and specific notes ring. Polarized radio maps, patiently integrated, lay down the orientation of magnetic fields like combed hair along the arms. The fields thread the dust lanes where gas streams, and their direction changes at shocks where arms compress matter. The vectors do not control destiny, yet they shape texture. Gas clouds resist collapse when magnetic tension and turbulence add to support, but they also slide more easily along coherent lines. The result is a neatness in the dust lanes, a clarity in the lanes that lead gas inward along a bar, a well-groomed path to the circumnuclear ring that often feeds a starburst. Farther inward still, infrared spectrometers sample the warm dust and the molecular gas crowded into a few hundred parsecs. The ratios of emission lines and the shapes of continuum spectra become thermometers and barometers. They reveal radiation fields strong enough to lift grains, shocks that widen the lines, and densities that push clouds toward quick destinies. Outflows appear as blue shifted absorption and as conical nebulae of ionized gas. They do not empty a galaxy. They ventilate it, lifting metal-enriched gas into the halo, where some will fall back as a rain that continues the cycle at a gentler pace. An optical spectrum taken across a disk adds another layer of order. The ratios of oxygen and nitrogen lines to hydrogen reveal metallicity, a memory of how many generations have lived and died in each region. A gradient appears, highest near the center, lower near the edge. The slope, when compared across barred and unbarred systems, tells whether radial mixing has been vigorous. Bars tend to flatten the gradient by stirring. Disks without strong bars often maintain steeper declines. Migration of stars across corrotation spreads ages and metals, softening sharp borders. Even in that mixing, a smoothness prevails. Histories differ, but converge toward gentle slopes rather than jagged jumps. High-resolution imaging of edge-on systems turns dust into a stencil. Thin lanes slice across bulges and flare at large radii into gentle warps. Warps record the conversation between disk and halo, or between disk and the flow of fresh gas drizzling in from the cosmic web. The curves change slowly over time, but they remain symmetric enough to steady the eye. A warp is not a wound. It is a reminder that a disk has flexibility and can accept torque without shattering. Gravitational lensing, an accident of alignment, supplies mass maps that need no assumptions about light to mass conversions. A foreground galaxy or cluster bends the light of a farther one, and the amount of bending reveals the density profile of the intervening mass. These reconstructions consistently support the story of extended halos, inner bulges, and disks nested like shells. The geometry that calms a photograph has a measurable backbone that lensing recites with quiet authority. Catalogues that run to hundreds of thousands combine individual portraits into demographic truths. The ratio of star formation rate to stellar mass, the so-called specific rate, separates actively building disks from calmer, redder populations. The boundary moves with cosmic time as the universe's supply of cold gas wanes, but the relation keeps shape. At fixed mass, environments nudge galaxies upward or downward in activity. Satellites in clusters often show stripped gas and quenched disks, while field spirals keep their reservoirs. These trends take wind from the sails of anecdote. The calm structures that soothe a viewer are not exceptions. They are products of a broad climate. Where starbursts concentrate in central rings a few hundred parsecs across, Careful mapping finds that the gas surface densities, pressures, and orbital times combine to set star formation efficiency. The short clock does not violate the larger theme. It plays a faster movement inside the symphony. Feedback from massive stars, radiation pressure on dust, and supernovae limit how far the fever runs. The gas cannot pile beyond a threshold without blowing its own safety valve. The burst ends, the ring dims, and the disk resumes a slower breath. Measurements of outflow rates compared to formation rates show near parity in many cases, a sign that the system prevents runaway. Black holes at centers announce themselves with broadened emission lines or with high-energy spears that puncture the halo. X-ray and radio images resolve cavities in the hot medium where jets have pushed, like an oar through a lake. Energetics derived from these cavities match what is needed to offset cooling in massive systems. The regulation is not mystical. It is thermodynamic bookkeeping that happens to carve clean bubbles as it balances the ledger. In some disks, the central engine idles and the circumnuclear ring plays the louder part. In others, the engine flares and star formation yields. The toggling is not a switch flipped in panic. It is a seesaw that rests, often near level. A relation between rotation speed and luminosity repeats from small spirals to grand designs. Faster rotating disks shine brighter. The scatter is small enough to use the relation as a distance tool and large enough to reflect differences in gas, age, and structure. The existence of the relation hints at a shared script for how halos acquire gas and how disks convert it into starlight. A quiet rule lives beneath the thousands of individual histories. The same spirit animates the connection between stellar mass and metallicity, written across wide ranges of type. Systems that forged more stars hold more metals, a steady accounting that feels reassuring in its simplicity. When near-ultraviolet images reveal star-forming knots in regions far beyond the optical edge, the surprise is softened by kinematics that show extended gas disks. The outer reaches rotate in step with the inner parts, and the shear remains moderate enough to allow small associations of stars to form. These outskirts do not host crowded fireworks. They host a sparse sprinkling of blue clusters that twinkle gently in a dark that would otherwise remain blank. The finding adds grace to a rim once thought dull. Taken together, these measurements form a choir that sings of resilience and design without a designer. The disk is not fragile glass. It is tempered. The bar is not a rigid rod. It is an orbit family that gathers and releases gracefully. The ring is not a fence. It is a resonance that lingers. The arm is not a painted line. It is a traveling density crest followed by a relaxing trough. The core is not a guaranteed catastrophe. It is a negotiator, sometimes enforcing rest, sometimes permitting bloom. Numbers and maps do not drain the wonder. They explain why a gaze at a galaxy lowers the pulse. Order survives scrutiny. The closer the look, the more convincing the calm. A spiral looks simple until the details arrive. An image suggests a single pinwheel. Then a spectrograph reveals that patterns can move at different rates in different parts of the same disk. One set of arms drifts with a tempo near corrotation. A bar turns with a quicker beat. A faint outer pattern lags behind like surf trailing a wave. If a spiral were one song, it would be easy to explain. The data suggests a small orchestra with overlapping melodies, each insisting on its own time. The calm image remains, but the score grows layered, and the mind feels a pleasant unease, as if a familiar tune had gained hidden harmonies. Some disks show flocculent arms, a soft patchwork of short segments rather than a grand design. These arms do not persist as coherent structures for long. They appear where gas collects, they brighten with young stars, and they fade after a few rotations. A viewer might expect such restless stitching to dissolve into confusion. Instead, the patchwork keeps reappearing, always different in detail and always the same in character. The mystery lengthens. A disc can look serene even when its embroidery is constantly being redone by local instabilities and swing-amplified ripples. Serenity, then, is a property of statistics rather than of a single long-lived pattern. Bars raise the stakes. Some are strong and crisp, others are faint, and a few appear to be fading. Simulations suggest that bars can buckle and thicken, producing bulges with the profile of a shallow box. Observations of edge on galaxies show exactly such shapes, a quiet architectural surprise. Yet bar fractions across cosmic time do not rise or fall in a simple way. Gas can weaken a bar by flowing inward and changing the mass distribution, but accreted gas can also regrow a bar later. A galaxy may pass through several ages of symmetry and revision. The metronome keeps time, then resets, then returns, and there is no single rule that predicts which path a given disk will take. Counter-rotation complicates the picture further. In some lenticulars and spirals, gas spins one way while a population of stars spins the other. Separate episodes of accretion leave their signatures like faint hands on a clock that turn backward at midnight. The overall structure looks untroubled, but inside the rotation map a quiet argument unfolds. The disk has accepted material from different sources without breaking. It has stitched opposites into a stable compromise, yet the sense of a clean narrative gives way to a story with chapters missing. There are galaxies with rings that appear without a visible bar, suggesting that resonances can be driven by weak oval distortions or by past companions now gone. Others wear rings offset from the center, as if an unseen tide had pulled them sideways. Some hosts display spirals inside spirals, small patterns nested within large, each with its own scale and speed. A person expecting a single engine behind spiral order meets instead a family of generators, each capable of writing calm curves that overlap without tearing the page. Dark matter halos, once a simple cushion around the disk, also acquire texture in the discussion. Measurements near centers of small galaxies prefer gentle cores of density rather than steep cusps, a hint that the luminous parts have pushed back on the invisible through repeated blasts of energy from star formation. Elsewhere, massive ellipticals seem to honor the steep profiles expected from unheated collapse. A few large, diffuse galaxies challenge expectations by appearing dim in the usual markers of dark mass, while hosting rich systems of star clusters. The classifications blur, the halo still steadies, but its shape and conversation with the disk depend on histories too varied to reduce to a single phrase. Quenching and renewal add more shade. Many massive disks ease their star formation until they glow red and quiet. Yet signs of later rejuvenation appear in some, a frosting of young stars that hints at fresh gas falling in long after the main building is done. The calm face hides a past of pulses, long seasons of rest punctuated by brief springs. The order remains, but the path to that order admits loops and returns that make prediction a gentle art rather than a sharp calculation. Cores that burst with star formation complicate feedback as well. Outflows blow cones into the halo, but not all bursts end with the same swiftness, and not all halos respond with equal generosity. Metallicity gradients that seem smooth in one system appear inverted in others during periods when inflow from outside dilutes the center. The neat slope becomes a temporary staircase set upside down. Afterward, mixing and fresh generations smooth the steps once more. The pattern reasserts itself, yet the memory of its inversion lingers as a reminder that rules breathe. High redshift disks enter the field with yet another challenge. They carry more gas and higher turbulence. They swarm with massive clumps that shine like city blocks adrift on a river, and still they rotate in an organized way. The rotation curves stay near flat despite the commotion, and the clumps migrate inward on timescales short compared to the age of the universe. Those migrations can build compact centers that later puff into warm bulges. The sight of order amid youthfully rough conditions contradicts the idea that serenity belongs only to mature systems. The script for calm begins early, but the scenes are noisier than expected. Migration inside the disk unsettles the tidy correlation between a star's age and its radius. Orbits change slowly through interactions with spirals and bars, moving stars far from their birthplaces without heating them excessively. The result is a gentle blur in the record that astronomers try to read from ages and metals. A single radius now contains many histories. The gradient smooths, the scatter grows, and the neat diagram in a textbook softens into a watercolor. The disk looks as poised as ever, but the genealogy of its stars is no longer crisp. An observer must accept that calm can contain the footprints of many quiet journeys. Gas accretion from the larger web adds one more twist. Streams can arrive, misaligned, they can tilt a disk, and they can supply fuel that spins at odds with the existing flow. The disk flares, warps, and then often finds a new plane. Some galaxies grow polar rings, spectacular structures where gas orbits at right angles to the main disk. Seen face on, the host looks like a placid oval with a halo ring of luminous smoke. The engineering is complex, but the finished form is oddly soothing, a compass rose drawn in starlight that could have been a celestial accident or a long plan. Black hole growth and galaxy growth scale together on average, yet the correlation hides flicker. The central engine brightens for short spurts, then dims, while the galaxy changes on much slower timescales. The connection is real but loose in any given moment. A snapshot can show a quiet disk with an unexpectedly loud nucleus or a thriving ring, without any sign of recent accretion onto the whole. The balance that keeps a system near steady climate is not achieved through constant attention, it is achieved through rare corrections with long shadows. This delays any simple cause and effect and lengthens the list of patient questions. Even the laws used to interpret rotation curves invite debate. Some researchers test modifications to gravity that attempt to reproduce the flatness of curves without invoking halos. These frameworks sometimes match specific relations with startling economy, then stumble on others that halos handle well. The conversation itself becomes part of the deepening mystery. If two models build similar calm surfaces from different foundations, which foundation is the truer bedrock? The question is not merely technical, it touches the comfort derived from a single story. Every new instrument sharpens the image of calm and reveals another subtle complication beneath it. Arms that looked smooth gain feathers, feathers split into spurs, and spurs harbour star-forming knots that rise and fade. The mind keeps both levels in view, the picture that quiets and the mechanism that writhes with mild agitation. The relaxation does not leave, it acquires texture. The mystery is not noise undercutting beauty. It is beauty recruiting noise into its design. A viewer ends the session with a paradox held gently rather than tightly. Galaxies appear restful at a distance and restless nearby. They keep averages with care while allowing details to roam. Patterns start, stop, and restart with new actors, while the stage remains familiar. The larger question grows more interesting rather than more confused. What makes a system so full of opportunities for mischief arrive, again and again, at shapes that invite a long breath? The answer appears close, and then moves a little farther, like a calm light receding by a precise amount each time one steps forward, not a retreat, not a tease, but an invitation to keep walking with quiet curiosity. A quiet room, a desk light, and a blank page invite a question that feels older than algebra. What principle allows wheeling islands to keep their grace while every constituent moves with impatience? The mind gathers hypotheses like shells from a shore, arranges them, and listens for a theme that might connect them. Theories do not arrive as thunder. They arrive like tides, each with a long reach, each leaving patterns in the sand that look, from a distance, like law. One family of ideas treats a spiral not as a static object, but as a wave that travels through a rotating disk. In this view, a density crest moves the way a traffic jam moves along a highway while cars drift through. Stars and gas enter the crest, slow slightly, pile together, ignite clusters, then exit and scatter. The pattern can persist without individual elements being glued to a curve. The comfort here is conceptual. If the arm is a moving shape rather than a painted stripe, it can last longer than naivete allows. The wave can be sustained by the disk's own gravity and by the delicate balance of shear and self-attraction. A crest that is neither too strong nor too weak keeps reappearing, like a polite thought that returns without insisting. A companion idea adds vitality to this wave. Local disturbances in a sheared disk can be amplified as they swing from leading to trailing. A small patch of overdensity stretches, gathers additional mass through its gravity, and grows into a segment that resembles an arm. The process is quick relative to cosmic clocks and can recur repeatedly. In this picture, the disk is not handed a finished spiral. It makes many short arcs that align into a larger motif. Serenity becomes a statistical product of endlessly renewed fragments. The arm never stops forming, yet the eye reads a continuous curve. Mathematicians have also mapped families of orbits in barred potentials and found that stars can travel along paths that crowd into coherent lanes. These orbital families act like scaffolds. Gas follows, shocks where lanes converge, forms stars, and paints the bar and the inner spirals with fresh light. The bar is then not a rigid object, but a choreography of compatible paths, and the arms are streams that meet those paths at resonances. The pattern speed that characterizes the bar sets the rhythm for the rest of the disc. A single number, the rate of the bar's turn, becomes a conductor's baton. The dark halo extends the stage and changes the script. Its gravity keeps the rotation curve flat, lengthening the zone where waves can propagate and stabilizing the disc against violent collapse. Yet the halo is not a silent mass alone. If baryons push and pull through repeated episodes of starbirth and outflow, the central halo profile can soften. A dialogue develops. The visible disc sculpts the invisible cradle, and the cradle shapes the visible disc. This mutual adaptation hints at a broader principle. Long-lived order may emerge when two components with different response times negotiate. The halo answers slowly, the disc answers quickly, and the compromise draws smooth light. Some propose that gravity might obey a different rule at the gentle accelerations found in outer disks. If so, the flat rotation curve is not a signpost to hidden mass, but a change in how force scales with distance and speed. The appeal of such a framework is its economy in matching certain relations between mass and motion. The challenge is its frugality in other arenas. The speculative comfort is philosophical. Perhaps nature prefers a single luminous ledger rather than a double book with one visible column and one dark. Either path, halos, or altered gravity seeks a way to preserve order without stretching credulity. The choice remains an open door. Magnetic fields add a quiet thread to the weave. Although they are weak compared to gravity, they align dust and channel gas. In doing so, they can sharpen dust lanes at the inner edges of arms and bars, slow the collapse of clouds in some regions, and ease it along preferred directions in others. Cosmic rays, born in supernova shocks, couple to those fields and push outward, helping to lift fountains of gas from disks into halos. The fields and the rays redistribute energy without tearing the fabric. They provide a pressure that is soft, pervasive, and hard to see. Theories that include them find that order gains resilience. The lanes that calm the eye are not only the product of gravity and rotation, they are also the work of lines of force that behave like invisible brushstrokes. Feedback closes another loop. Massive stars bathe their surroundings in photons, stir the air with winds, and end in explosive shells. These processes can blow holes, but they also compress nearby gas and set the stage for the next round of formation at the rims of cavities. The interplay between destruction and creation produces a regulated pace. If star formation begins to run too fast, feedback heats and thins the fuel. If it slows too much, cooling restores density. A thermostat emerges from chaos. Theories that encode this self-regulation often recover global relations between gas surface density and star formation rate. The relief lies in the idea that order does not need an overseer. It can arise when processes that seem wild on small scales sum into restraint on large scales. At the center, a supermassive black hole provides a different kind of governor. When gas feeds the hole, radiation and jets can heat or expel surrounding material. In massive systems with hot atmospheres, this input prevents the gas from cooling too quickly and falling to the center, where it would make stars at a pace that observations do not support. In more modest disks, a quieter engine may coexist with a circumnuclear star-forming ring that handles the local economy. The speculative bridge is that both regimes follow a principle of marginal stability. Gas hovers near the threshold, where collapse becomes efficient, pushed up or down by central feedback. The system avoids both famine and feast. Environment enters as an external composer. Tidal encounters can seed a bar or reinforce a spiral, while ram pressure in clusters can strip gas and silence a disk. Theories that include gentle gas inflow from filaments predict long epochs during which a disk is fed at a rate matched to its capacity to turn gas into stars. When inflow is smooth, symmetry thrives. When infall is clumpy, asymmetries appear, then wash away as the disk recovers. The calming thought is that the cosmic web does not simply dump fuel, it often delivers with a cadence that disks can digest. A wider speculation treats a galaxy as a thermodynamic engine that maximizes the rate at which it moves energy down a gradient without destroying its own structure. In this view, patterns like spirals and bars are efficient conduits for angular momentum transport. They allow gas to lose energy, drift inward, form stars, and recycle material while keeping the disk thin and usable. The pattern is not an ornament, it is plumbing that also happens to be beautiful. Serenity becomes a sign of efficiency in the management of flow. Another line of thought borrows language from ecological systems. Disks, bulges, halos, and black holes play roles akin to producers, reservoirs, regulators, and apex sinks in a network of exchange. Feedbacks create negative loops that stabilize, while occasional positive loops trigger brief blooms. Diversity in orbit families offers redundancy that preserves function when one pathway weakens. The analogy is imperfect, yet it helps to imagine how many routes can lead to similar outcomes. Patterns that recur across systems of different mass and history suggest convergent solutions to shared constraints. Information theory provides a subtler angle. Spiral arms and bars increase predictability in the positions of gas clouds and the timing of star formation along specific lanes. By correlating the behavior of many elements, these patterns reduce randomness and concentrate complexity into narrow regions. The result feels ordered because it is ordered not only in geometry but in the flow of cause and effect. Theories that measure correlation lengths and coherence times within disks could one day quantify the very sensation of calm that a photograph evokes. Speculation also dwells on time near the edges of visibility. In faint outer disks and low surface brightness systems, gravity treads lightly and gas densities hover near thresholds. There, small perturbations may decide whether a ring of star formation lights or remains dark for an epoch. A mild compression from a passing satellite, a change in radiation background, or a ripple from the inner disk could tip the balance. The frontier becomes a laboratory for marginal processes that, when integrated over the whole, still produce the familiar profile of fading light. The delicate rim teaches that serenity can survive on a thin budget. Future instruments will test these ideas by mapping gas motions at scales where turbulence yields to gravity and where magnetic tension competes with shear. The hope is not a single law that explains all curves. The hope is a modest unification that shows how a handful of principles set the conditions under which many disks choose similar solutions. If prediction can reach from dark halo mass to bar probability to arm character to star-forming efficiency, then the long arc from chaos to pattern will feel less like a miracle and more like a craft. Even with such progress, a residue of wonder will remain. Theories can say why a spiral endures and why a burst ends, yet the human response to these answers is part of the subject. Calm arises when a mind sees that many paths lead to a narrow creek where light flows without turbulence. That creek is the zone of predictable pattern, the place where waves, orbit families, feedback, field lines, and halos agree for a while. The speculative charm is that agreement does not require a command. It arises because the simplest long-lived forms are selected by persistence. Spirals and bars last because they can last, and because the universe has time to reward anything that maintains itself without waste. Night science walks on quiet feet. A dome splits, mirrors awaken, and instruments take their places like musicians tuning for a long recital. The question is simple: how to prove that calm forms in galaxies are not illusions? The path is patient. Measure, compare, repeat, and when possible, design new eyes that see what older eyes could not. Each tool bears a temperament. Some love faintness, some love speed. Together they practice verification, like a craft. An array of radio dishes faces a sky that never truly sleeps. At centimeter wavelengths, cool hydrogen speaks with a single line that slips through dust with ease. Interferometry stitches far antennas into a single sharp ear, drawing maps of gas that spans from center to rim. Motions become readable as gentle gradients across the face of a disk. Warps lift in profile like a bowed plank on a lake. Extended arms carry reservoirs that stars will sip for ages. In the same band, polarization reveals the alignment of magnetic fields. Vectors trace along dust lanes and curve through bars towards circumnuclear rings. Observers compare those maps to kinematic models and decide if a wave orbits wave, or if both share the work. At millimeter wavelengths, a mountaintop is chosen for dry air. A linked set of dishes listens for molecules that gather in clouds thick enough to hide their hearts. Carbon monoxide hands over a census of the densest fuel. Higher transitions give temperature and density clues. With such data, astronomers test whether star-forming efficiency climbs predictably with surface pressure, and whether feedback from newborn clusters opens cavities that interrupt runaway collapse. The arrays move with the seasons, yet the stories they tell are steady. Gas flows inward along bars, gas piles into rings at resonances, gas drifts outward again in fountains pushed by young giants and by cosmic rays that favor magnetic paths. Optical telescopes hold their breath behind adaptive optics. A guide star, real or born from a laser, lets a mirror flex hundreds of times per second. The atmosphere becomes less of a tremor and more of a veil. Slit by slit, or lenslet by lenslet, integral field spectrographs transform each galaxy into a cube of light where every small tile has a spectrum. From this cube, velocities of stars and gas are recovered, dispersions become maps of pressure, and line ratios diagnose ionization. A ring bright with H-alpha marks where orbits exchange families. A twist in velocity near the core whispers of a bar. The oxygen gradient resumes a gentle slope once the bar has finished its stirring. The instruments do not claim authority. They offer evidence that any careful mind can follow from pixel to plot. Space telescopes keep watch beyond air and weather. In ultraviolet, the shortest-lived stars write recent history as points and arcs along arms. In infrared, dust warmed by those same stars outlines lanes that feed the center. Mid-infrared bands separate aromatic molecules from hot continuum, separating photodissociation regions from embedded clusters. Far infrared views weigh total dust and infer the gas that dust accompanies. X-ray observatories look into the halo and find cavities where jets from central engines have sculpted bubbles. The energy required to blow those holes is compared with the energy that must be offset to keep hot atmospheres from cooling too quickly. The numbers balance often enough to suggest regulation rather than accident. Surveys that watch the whole sky trade intimacy for sample size. A wide field mirror scans night after night, collecting multicolor images with a cadence that turns time into another axis of measurement. Variability reveals active nuclei by their quiet flicker. Supernovae trace star, forming regions as they appear and fade like lanterns in rain. Tidal features around otherwise composed disks grow more common the deeper the stacks go. Streams of stars curve like ghost rivers, evidence of swallowed companions. With each additional year of imaging, the background becomes a soft reservoir of past disturbance, often wrapped around a present that looks serene. Calm persists, yet the path to it is recorded in faint ink. Gaia, like astrometry, turns the nearby sky into a moving mosaic. Positions of stars in the Milky Way change by milliarc seconds over months and years, which is enough to reveal streams and resonant ridges in the local disk. While this experiment occurs at home, the method tests the physics that underpins disks everywhere. It verifies that bars and spiral patterns can sculpt velocity space into arches and gaps, subtle signatures of orbital families. The result is a confidence that the same sculpting power acts in distant systems where individual stars cannot be resolved. Strong lensing supplies experiments in gravity that would be impossible to arrange in any laboratory. A foreground galaxy bends the light of a background one into arcs and rings. Tiny distortions in those arcs betray substructures in the lensing mass that carry little or no light. In this way, theories of dark matter meet a direct challenge. How many small clumps exist? How dense are they? The answers feed back into rotation curve models and predictions of how bars slow through friction with the halo. Lensing does not simply confirm invisibility. It counts and weighs the invisible with a ruler made of warped starlight. Numerical simulations serve as rehearsal spaces where physics can be turned like knobs. Gravity is exact. Hydrodynamics is costly but faithful. Cooling, star formation, feedback, and magnetic fields enter through recipes that are refined as observations complain. A galaxy grows inside a digital halo that accretes mass from a cosmic web modeled from initial fluctuations. The code births a disk, grows a bar, seeds a bulge, and sometimes launches a wind. The synthetic images are measured as if they were real. If they reproduce the tight relation between rotation speed and luminosity, or the size of rings at resonances, or the frequency of bars at a given mass, trust increases. Where they fail, a new term is examined or a threshold is reset. Simulations are not films of truth. They are arguments that can be strengthened or disproved with data. Machine learning searches this growing archive for patterns that elude manual eyes. Networks trained on classifications propose a probability that a faint smudge is barred or unbarred, flocculent or grand design, ringed or plain. Another network estimates star formation rate and dust content from broadband colors alone, then cross-checks those estimates against spectra. Yet another highlights tidal debris at the edge of detection, lending support to the idea that many quiet disks have histories inked in pale script around them. The risk is bias, smuggled in through training. The protection is an honest loop of prediction and follow-up with independent tests. When the loop closes neatly, confidence grows without swagger. Facilities still rising promise further calm verifications. A giant segmented mirror will resolve stars in distant disks well enough to read their ages from spectra, tag their chemistry element by element, and map migration by seeing where old populations have wandered. A Roman-class surveyor will measure weak lensing across enormous fields, linking the shapes of galaxies to the growth of structure in ways that test the backbone of cosmology. A low-frequency radio array will map neutral hydrogen across cosmic dawn and trace the gradual filling of space with light, tethering present patterns to their earliest scaffolds. The day each instrument first sees the sky is not the end of doubt. It is the beginning of measured answers. Laboratory astrophysics supplies constants without romance but with grace. Cross-sections for cooling, rates for molecule formation on dust, opacities for grains of mixed composition, and yields for metals from different kinds of supernovae all feed the models that stand behind every figure. These rates are checked, updated, and sometimes overturned. A small change in a recombination coefficient can tilt a whole ladder of line ratios. A revised dust opacity can reshape estimates of gas mass. The humility of this work keeps grand claims honest. Calm needs good numbers. Time domain campaigns expand the notion of serenity by letting transients play without rewriting the script. In a starburst ring, a cluster shines, a handful of massive stars die, shells expand, and then the ring returns to a steady glow. The statistics of explosions measured over many rings match the rate implied by the current formation. Feedback paints itself in arcs and filaments that drift outward and disperse. The frame that holds these events is steady on larger scales. Variability inside does not negate stability outside. Watching both together removes the last excuse for mistrust. Finally, comparative anatomy across environments answers whether calm is provincial. Clusters with hot intracluster gas strip spirals tilt them and sometimes quench them. Fields and small groups let spirals keep their gas and grow bars. At filaments, inflow continues. At voids, accretion slows. By sampling each habitat with the same instruments and metrics, astronomers show which patterns are robust to change and which depend on gentle supply. The conclusion that emerges is nuanced. Serenity is common but not universal. Where it is found, it is earned by balances that can be named, measured, and imitated in models. In this long practice of testing, beauty is not protected by distance or by vagueness. It is examined at scales from parsecs to megaparsecs, at wavelengths from radio to gamma rays, with tools that either agree or disagree in public. The reward for this discipline is a deeper relaxation. A viewer can look at a spiral or an oval and know that its calm face is not a trick of exposure or an antique optimism. It is a surface expression of many processes that hold one another in check. The dome closes. The instruments rest. The data survives the night and goes on to join an archive that grows like a patient glacier, slow, clear, and strong. A galaxy can be read by light and motion, yet another script runs through it, quieter than gravity and softer than starlight. It is written in lines that cannot be seen with the eye. It is felt in the way dust aligns, in how charged particles turn, in the hush of radiation that comes when electrons spiral through a field they cannot leave. Magnetism threads the disk like an invisible embroidery, binding clouds, guiding flows, and shaping the texture that settles the gaze. A radio map reveals this script first. Starlight bounces from dust and glows with color, but synchrotron emission murmurs in long wavelengths that cross the galaxy without hurry. Polarization angles trace the direction of the field as if a comb had been drawn through the disk. Vectors curl along arms, bend around bars, and rise into halos. The pattern is not random. The field keeps a pitch angle close to the curve of the arms, as if it shares the same spiral logic. Where gas shocks along an inner edge, the field sharpens and slides, then resumes a graceful sweep. The eye follows those lines and discovers a second set of arms whose ink is force rather than starbirth. The origin of this order lies in a slow engine. A rotating disk with turbulence and shear can grow a magnetic field from whispers to audibility. Motions of ionized gas wind and fold seed fields, and reconnection resets tangles into larger coherence. A dynamo operates, patient and persistent, converting kinetic energy into magnetic structure. On small scales, eddies churn and amplify. On large scales, the effect of rotation and stratification builds a global pattern that remembers the spin of the disk. The result is a field that is neither uniform nor chaotic. It is a garden of lines that know their curve. Gravity and magnetism converse without rivalry. A cloud that begins to collapse carries its field inward, and the field resists contraction sideways more than along its own lines. Collapse becomes anisotropic. Filaments appear, fine as hair, and stars begin along these threads. In dense cores, ambipolar diffusion lets neutrals slip past the field once the ionized fraction grows small, and collapse completes. On wider scales, magnetic pressure adds to turbulence in supporting a patch of the disk against catastrophic fall. The same field that permits flow along its length slows motion across it. Gas takes the paths that cost less energy. Bars feed centers by lanes that align with the lines of force and avoid the lanes that would fight them. The field is not a wall, it is a suggestion that matter accepts. Cosmic rays add a partner to this influence. Born in shocks and distributed by motion, they ride the field like passengers with a preference for smooth roads. Their pressure helps lift gas from the plane into a fountain that rises, cools, and returns. In Edge on Galaxies, radio halos show X-shaped patterns where fields open above the disk. The shape is gentle and symmetrical, a sign that outflows are not always violent ejections but often steady exhalations. These lofted lines also matter for chemistry. They carry ionization into thick clouds, setting the balance of states that determine how quickly molecules form and how readily gas couples to the galactic beat. At the inner few hundred parsecs, where orbits change families and rings gather fuel, the field takes on the neatness of city planning. Polarization maps twist around the ring and point inward along dust lanes that cross the bar. Gas streams down these lanes as if drawn by arrows painted on a road. In the ring, the crowding of orbits compresses both gas and field, and star formation ignites in arcs that look precise, even when the underlying dynamics are messy. The field stabilizes the lanes against fragmentation and delays collapse until the ring is reached. Efficiency rises, where geometry and magnetism conspire to pause, gather, and then allow. Farther out, in the flocculent disks where arms are not long, the field still finds coherence. Short segments align into larger stretches. A patchwork of order coalesces from local processes. Swing-amplified ripples and magneto-rotational instabilities combine to shape small structures that the field then prolongs. The viewer sees soft arms that are not quite continuous, yet the polarization vectors tell a smoother story. There is comfort in this persistence. Even where the luminous spirals hesitate, the lines of force continue the curve the eye expects. Evidence for the strength and direction of the field accumulates by patient methods. Faraday rotation twists the plane of polarization for background sources that shine through a galaxy. The amount of twist counts the magnetized electrons along the path. A grid of such measurements becomes a tomography of the field, revealing reversals, vertical components, and differences between arm and interarm. Zeeman splitting offers direct, local strengths in dense regions where emission or absorption lines are narrow enough to show the effect. Dust polarimetry in the submillimeter adds the alignment of tiny grains as a vote for orientation. Together, the techniques sketch a map that no single instrument could draw. The field also meets its tests in places where pressure rises abruptly. At the edges of expanding shells, lines gather and brighten in polarization. Behind bow shocks around superbubbles, vectors drape like fabric pulled tight by wind. In tidal streams, the field follows the stretched material yet keeps a memory of its original direction. Such scenes reveal both the flexibility and the resilience of structure. The field is stirred but not broken, gathered but not trapped. It behaves like a quiet medium that absorbs energy and returns it as guidance. At the very center, within a few tens of parsecs, peculiar threads appear. They run nearly vertical, thin and luminous in radio, as if someone had combed the air near the core. Their origin is debated. They may be magnetic flux tubes illuminated by particles accelerated near the nucleus. They may be boundaries between flow regions with different rotation. Whatever their cause, they remind the mind that magnetism can hold shape even in the furnace of a nucleus. Calm can be drawn with a fine pen where chaos might be expected to splatter. Spiral arms owe part of their clarity to the field. Gas that shocks at an arm's inner edge carries lines that reinforce the compression, which heightens contrast between arm and interarm. Downstream, where new stars have emerged from cooled gas, the field relaxes and resumes a gentle angle shaped by shear. The sequence repeats, arm after arm, turning dynamical wave into a visual lane with crisp borders. In numerical experiments that include both gravity and magnetism, arms that were fuzzy become sharper and more continuous. The magnetic tension reduces the tendency for spurs to tangle and helps filaments remain parallel long enough for star formation to proceed along them in a cadenced way. Halos preserve another kind of order. Fields open and connect into large loops that carry energy and material between the disk and the environment around it. These loops shape the way hot gas cools and falls. They change how short-lived ions mix. They even affect how long it takes for metals forged in stars to reach the outskirts. The timescales are long, the lines extend for kiloparsecs, and the impression they make is one of structure arranged for exchange rather than for hoarding. A galaxy does not only keep its calm by internal balances, it also keeps it by polite traffic with its surroundings, and magnetism draws the lanes for that traffic. There are instabilities that live on these lines. Parker modes lift gas and field out of the plane in long undulations. At their crests, clouds can collect and collapse. Between crests, material slides back, feeding the next rise. The pattern is modest, but real. It adds a seasonal rhythm to star formation that statistical studies can discover if they watch long enough and wide enough. Magneto-rotational effects tap the energy of differential rotation and feed turbulence at a level that keeps disks near marginal stability. The field is both a beneficiary and a source, absorbing motion into tension and then returning it as gentle stirring. Not all the work is constructive. Reconnection allows lines to break and rejoin, releasing energy that heats gas and accelerates particles. In dense clouds, this process can change the ionization fraction and alter chemistry. In diffuse media, it seeds the disordered part of the field that observations still find. The presence of disorder does not erase the large pattern. It fills the gaps between ordered regions and gives the field the elasticity it needs to endure stress. Too much order would be brittle, too much disorder would be useless. The balance delivers resilience. A relation links magnetic strength to the vigor of star formation. Where clusters are being born, the field tends to be stronger, partly because compression enhances it, partly because fresh cosmic rays and turbulence pump energy into it. The connection is not direct at every point, but across regions it holds well enough to treat the field as both product and participant. This feedback keeps the galaxy from extreme states. Increase the formation rate, and the field pushes back by lifting gas and raising pressure. Decrease it, and the field relaxes, allowing new clouds to form. The galaxy steers toward a middle path, with the field as a subtle hand on the tiller. Viewed in total, the magnetic architecture gives the calm image of a galaxy another reason to feel grounded. Arms keep their pitch because the field follows and sustains them. Bars feed rings because lines guide gas toward the rendezvous. Halos flare with soft light because outflows follow ordered paths into the dark. Filaments in clouds point like compasses because the field tells them how to lie. This is not ornament, but structure. It does not outshine stars, yet it supports the shape in which stars make their home. Silence is a quality of magnetism in galaxies. It does its work without spectacle. It refuses to be seen unless someone brings the right radio ear or a dust-sensitive eye. The price of this quiet is patience. The reward is an answer to why the large picture holds steady while the small picture seethes. Lines of force resist randomization. They channel what could be a jumble into streams that minds can read. The next time a spiral glows on a screen, the final impression may still be light, but beneath that glow lies a map of threads, ancient and current, crowded and spacious, that keep the peace by giving motion a preferred way to proceed. City lights gather in a core no wider than a few hundred parsecs, and the spectrum turns warm with dust grains heated by new stars. The scene suggests a crescendo, yet the music refuses to rush. Gas arrives along lanes that cross the stellar bar and fold into a ring where orbits exchange families. There, clouds collide, compress and cool, and clusters ignite in arcs that look almost architectural. The pressure is high, the densities are blunt with gravity, and still the system hesitates at a grace note before the full chord. That pause is the first hint of self-control. Inside the ring, the free fall clock is short, but so is the range of balances that can be maintained. If clouds collapse too quickly, feedback from massive stars arrives almost immediately. Radiation pushes on dust, winds carve cavities, and supernovae lace the medium with hot, fast plasma. The result is not an explosion that empties the city, but a network of chimneys and fountains that vent excess energy. Warm gas traces conical shapes above and below the plane, narrow near the roots and blossoming outward. Hotter phases fill bubbles that shine in soft X-rays, while cooler phases thread the edges in filaments that carry metals outward like seeds on a breeze. Each phase talks to the others about pressure, momentum, and the acceptable speed of brightening. In the densest knots, the radiation field becomes so intense that dust becomes the critical partner in the conversation. Photons trapped by grains add to gas pressure and set a ceiling on how rapidly stars can form before radiation force lifts the curtain. The limit behaves like a local Eddington balance for dusty gas. Push harder, and the system responds by opening pathways for light and matter to escape. Pull back, and collapse proceeds again until the thermostat clicks. The burst rises and falls in waves, never perfectly periodic, always near a threshold that the medium remembers even as clouds come and go. Star clusters are the protagonists of the drama. They form with masses that range from modest associations to superb gatherings bound tightly enough to survive. Their winds and ionizing light carve spheres that merge into cavities. Their supernovae arrive on a schedule that is short compared to the life of the burst, but long enough for shells to overlap. These overlaps build porosity into the core. The higher the porosity, the easier it becomes for pressure to vent through channels. The ease of venting sets the slope of the relation between gas surface density and the rate of formation at the highest densities. The slope is steeper here than in open disks, yet it does not run away. The city chooses breathing over burning. Kinematics within the ring show streaming motions that load fuel into star-forming arcs, then carry material around to quieter quadrants where young clusters begin to age. In these flows, turbulence is not only a byproduct, it is a structural element. It thickens the disk against gravitational collapse, lifting the effective stability parameter to a value near unity. Too little turbulence, and the ring would fragment into a storm that chokes on its own success. Too much, and the ring would starve itself. The measured dispersions sit in the middle, large enough to resist cascades, small enough to allow continued formation where shear and compression meet. Outflows set the larger stage for balance. At their base, line widths are broad and densities high. Farther out, speeds approach escape values in some channels and fall below in others. The result is a split fate. A fraction of material leaves the galaxy for good, carrying fresh metals that will decorate intergalactic space. Another fraction stalls and returns as rain, after cooling and mixing in the halo, This fountain replenishes the outskirts and eventually finds its way inward through warps and filaments. The timescale is long compared to the burst itself, which means that self-regulation gains a memory. Past vigor becomes future supply at lower density, smoothing cycles and preventing sharp contrasts between feast and famine. Chemical signatures reveal the pace and reach of this economy. In the ring, abundances are high, lines glow with the imprint of oxygen and nitrogen forged nearby, and ratios trace hard radiation fields around young clusters. Radial trends that fall away from the center flatten temporarily, while inflow and outflow exchange material. After the burst, gradients resume their descent, but with a new zero point that speaks to enrichment. Dust temperatures rise during peak activity, then cool as the ring dims, leaving a trail of far infrared color, changes that function like a diary. Nothing in this record suggests a catastrophe. It reads as a well-managed budget. A compact black hole may watch from the nucleus. When its diet thickens, a bright engine can join the chorus. The joining is not always simultaneous with the highest star-forming rate. Sometimes the engine kindles late, feeding on the inward spill from the ring after the burst has already softened. Sometimes it brightens first and delays the burst by heating the interior gas above the level where collapse is easy. What matters for calm is the combined effect on the pressure of the central few hundred parsecs. If the engine and the clusters push together too hard, the core clears and the burst ends quickly. If one dominates, the other waits. Duty cycles overlap like slow chords. The shared outcome is moderation. Observers weigh these processes with rates rather than anecdotes. The mass loading of the wind, the ratio of outflow to formation, often hovers near unity in starburst cores. This parity means that for every ton of new stars, a comparable ton of gas is carried outward, not lost entirely, but moved into a queue for later decisions. The depletion time in the ring is short, on the order of a few 100 million years or less, compared to the multi-billion-year clocks of calm outer disks. Short does not mean reckless, it means focused, and the focus is kept from narrowing into a blaze by the very pressure it creates. Geometry plays an unexpected part. The ring acts as a traffic circle where inflow is organized, collisions are frequent but moderate, and shear prevents giant structures from hoarding all the gas. Its circumference offers multiple initiation sites for clusters, distributing feedback around the circle so that no single quadrant controls the climate. Even when the ring breaks into a lopsided pattern, the system finds a new balance over a few rotations. The bar continues to deliver. The ring continues to digest. The nucleus breathes through vents that adjust their angles as the inner potential shifts with new mass. In the thick of the burst, the light can saturate detectors in standard bands, but radio and submillimeter windows stay open. Free emission from ionized gas offers a direct measure of the ionizing photons, relatively immune to dust. Recombination lines in the infrared count the same budget without the punishment of extinction. These measurements verify that the economy of the core is vigorous but accountable. Even at its most intense, the burst keeps to ratios that a theory of self-regulation can recognize. Numbers drawn from different tracers converge on rates that agree within their uncertainties, a sign that the process is not an erratic fire. Over time, the ring may hand its role to a compact bulge built from stars it has formed and migrated inward. As mass grows at the center, orbital families change and the bar can weaken. With less torque, inflow slows. Supply thins, the ring dims. This is not a failure of the system, it is a transition to a new architecture that inherits metals, dust, and a calmer pressure field. The outflows relax into fountains of lesser reach. The nucleus idles or flares briefly depending on residual gas. The city becomes a district in a larger, quieter municipality, and the memory of its fever remains as a smooth profile of starlight that swells gently toward the middle. A casual viewer might see only a bright heart and guess at a temper that cannot be contained. The deeper truth is kinder. Self-control is encoded in physics that cares about force balances, opacities, and the speed of information through a medium. Photons travel fast, winds carry momentum where it is needed, shocks redistribute energy where compression has hoarded it, and gravity keeps the meeting civil by insisting that everything still belongs to the potential. The core becomes a classroom where nature teaches control under pressure. The calm that spreads from such a center is not the calm of a desert, it is the calm of a harbor where traffic is heavy, but lanes are marked, tides are expected, and storms lift and pass without redefining the coast. In the end, what remains is structure. A ring that once blazed becomes a necklace of aging clusters. A bar that once fed grows subtler. A bulge that once was small stands taller and rounder. The galaxy carries on with a face that still invites long looks, and the heart that could have been a furnace turns out to be a regulator, bright but courteous, strong but measured, a keeper of pace in a universe that never stops moving. At the quiet center of many galaxies waits a gravity well so compact that light itself must choose a careful path. Around it, gas circles and warms until it shines, with a brightness that can rival 1,000,000,000,000 suns. The image of hunger is unavoidable, yet the behavior that emerges is closer to gardening than to unchecked appetite. A supermassive black hole trims, waters, prunes, and sometimes replants the surrounding medium, helping a galaxy keep its poise, even as matter falls toward a point that defies ordinary intuition. Accretion begins with a disk that forms from gas, losing angular momentum through collisions and magnetic stresses. Friction in that disk heats the gas to temperatures high enough to radiate from optical bands to X-rays. Above and below the disk, a tenuous corona bathes the region in harder light. Dust further out absorbs and re-radiates in the infrared, shaping a cocoon that sets the stage for what escapes and what returns. When the inflow grows thick, luminosity rises toward a limit where radiation pressure on electrons and dust competes with gravity. The system adjusts by puffing the inner disk or launching winds, keeping the pace near a level that the geometry and opacity can support. Two broad temperaments dominate the central influence. In one, a bright phase peels off layers of gas through wide-angle winds that carry momentum and heat into the bulge. The flow begins near the disk where line driving and radiation pressure push on ions and dust. As the wind expands, shocks convert ordered motion into thermal energy that inflates cavities and squeezes surrounding clouds. The outcome depends on density and structure. Some regions are cleared. Others compress into knots prone to forming stars along shells and filaments. The central engine neither always destroys nor always builds. It chooses both by circumstance. In the other temperament, power escapes through collimated jets that thread the surrounding plasma and lift into the halo. These jets owe their launch to magnetic fields that tap the rotation of the inner disk, or even the spin of the hole itself. As the jets pierce hot atmospheres, they excavate bubbles that rise buoyantly like lanterns in deep water. The work done to inflate these cavities often matches the energy lost by cooling gas in massive systems. Without the input, the atmosphere would condense into a cascade of new stars that observations do not find. With the input, the medium hovers near a thermal balance that prevents both frost and fire from dominating. The scale of influence is set by a conversation between gravity and pressure. Close in, within light days to light months, velocities are high and broad emission lines reveal orbits whipped by the central potential. Farther out, narrow lines arise in gas stirred by softer winds and by the ambient field of young and old stars. Orientation matters. In some views, the inner broad line region hides behind dusty walls, leaving a spectrum dominated by narrow features and a glow that favors longer wavelengths. In others, the inner tumult is seen more directly. The variety of faces does not imply a variety of engines. It implies familiar geometry seen from differing seats. A quiet relation links the mass of the black hole to the gravitational temperature of the bulge, measured by the random speeds of its stars. The correlation is not perfect for every case, yet it stands across orders of magnitude with a firmness that suggests co-evolution. When the center grows, it tends to grow in step with the city of stars around it. The path to this balance is a sequence of episodes rather than a single conversation. Gas flows inward through bars and spirals, reaches a circumnuclear ring, and then trickles to the very core where the last angular momentum is shed. The engine wakes, pushes back, rests, and wakes again. Over many cycles, mass gathers both in the hole and in the surrounding population, as if the two partners agreed on a budget without ever meeting face to face. Spin introduces another quiet parameter. A rapidly rotating hole can store and release more energy per unit mass accreted than a slow one, and it can collimate jets more effectively. Mergers of galaxies deliver black holes that eventually pair and then unite, changing spin through the vector sum of their angular momenta. Gas accretion can also align or counter-align rotation depending on the coherence of the inflow. The final spin helps set how forcefully the nucleus can ventilate the halo. A fast spinner tends to carve cleaner cavities. A slow one tends towards softer winds. Both modes help keep the climate poised near a state where cooling neither runs away nor stalls entirely. On the smallest scales, where the disk meets the corona, variability writes an erratic script. Brightness flickers over hours to days as magnetic reconnection heats patches and then lets them relax. Spectral slopes tilt and untilt as the balance between soft and hard emission shifts. These changes ripple outward through the broad line region over weeks to months, altering ionization and line strength with measurable delays. The delays sketch radii and reveal an architecture in depth. The fluctuations are weather, not climate. They stir without overturning the larger capacity to regulate. Outflows carry chemical stories. Gas peeled from the inner disk bears the imprint of high temperatures and hard photons. As it slows and cools, it mixes with ambient material that carries the longer history of stellar recycling. The mixture enriches the halo with metals that later join fresh inflow to the disk. Over time, the central engine acts as a fountainhead for elements forged throughout the galaxy, lifting them to altitudes where they can be redistributed without choking new star formation near the plane. Metals radiate efficiently. Their presence then alters cooling times and sets how quickly gas can return. The result is a feedback loop that tunes itself through composition as well as through heat and pressure. On larger scales, the imprint of central action appears as ripples and weak shocks in X-ray images of hot atmospheres, as filaments of cool gas that drape around the edges of cavities, and as radio lobes that fade with age into invisible reservoirs of relativistic particles. These signatures persist for tens of millions of years, long after a single episode of accretion has dimmed. They lend inertia to regulation. Even if the engine rests, the bubbles continue to lift, the filaments continue to exchange heat, and the atmosphere continues to settle toward a profile where cooling times lengthen near the radii, where cavities have delivered their work. There are rarer dramas that still speak to balance. When two black holes meet after a merger, their final union radiates away momentum in gravitational waves. The recoil can displace the remnant from the center. If the kick is modest, the nucleus wobbles and returns, stirring the inner gas and perhaps lighting a ring as it crosses resonances. If the kick is large, the hole wanders longer, and the galaxy must wait for dynamical friction to ease it home. Even here, the system tends toward a restored symmetry. The timescales are longer, the path more circuitous, yet gravity remembers where the center belongs. The outskirts feel the influence more gently. Jets that reach into group and cluster scales can shape the supply of cool gas that flows along filaments into the disk. Where the tap is moderated, inflow is smooth and symmetrical, feeding arms and bars without overwhelming them. Where the tap is forced shut, the disk ages and reddens. Where the tap is too open, star formation surges until feedback brings it back to heel. The central engine is not the only hand on the faucet. It is the hand with the longest leverage. A galaxy viewed across epochs shows that central regulation is episodic. Early times favor brighter engines when gas is more abundant and interactions more common. Later times favor maintenance through jets and bubbles that keep massive systems from reigniting. In smaller hosts, the nucleus often idles, while circumnuclear rings handle local balance. The full picture is a sequence of roles played by the same actor under different lighting. Each role seeks the same outcome: avoid extremes, maintain shape, share energy without hoarding or squandering it. Simulations that include central feedback recreate familiar forms with greater ease than those that do not. Disks remain thin despite frequent minor mergers because hot halos stay buoyant. Bulges grow to sizes that match the observed relation with black hole mass. Cooling flows stall at rates that match spectroscopic limits. These successes are not final proofs, yet they are persuasive rehearsals that show how a small engine can set rules for a much larger stage. The gardener analogy returns because it fits the effects. Prune here, shade there, open a channel for water to leave, and a chaotic yard becomes a place where growth follows lines that the eye can trust. The calm face of a galaxy owes part of its peace to this compact regulator. A viewer looking at an arc of starlight may not think of bubbles in X-rays or of winds laden with ions, yet those features hold the surrounding medium near conditions where stars can continue to form in lanes, where bars can rotate without choking on inflow, and where halos can cool without collapsing. The central black hole is a paradox that heals itself. It is the most severe curve in the geometry, and at the same time the author of gentleness in the neighborhood it inhabits. If the idea feels unlikely, it is because gravity at its most focused suggests ruin. The record says otherwise. Energy, released by accretion, does not only fall inward, it rises and spreads like heat in a home, preventing frost on one wall and dampness on another. The field of the gardener includes the vaulted ceiling of the halo, the crowded streets of the bulge, and the quiet avenues of the disk. The work is constant, but not loud. It is a series of corrections that keep an ecosystem poised near comfort. In that poise, shapes endure, and light learns to travel in curves that calm the mind. Clouds wander across a galactic disk like weather on a continent. A patch glows blue with newborn clusters, another dims as its fuel disperses, and between them lie stretches of neutral gas that breathe in time with gravity and starlight. The spectacle looks busy, yet the averages remain serene. A climate emerges from many local storms, a slow pattern assembled out of short tempests that never quite align. In this climate, gas divides itself into phases that share a pressure but not a temperature. Warm, neutral regions float near 10,000 degrees and hold their shape like gentle fog. Cold, neutral clumps cool to tens of degrees and collect in sheets and filaments. Hot cavities carved by supernovae and winds fill the spaces between, their tenuous plasma carrying heat and metals along tortuous paths. These phases exchange mass through evaporation, condensation, and compression, guided by a simple rule. Where heating balances cooling, a state endures. Where the balance tilts, the gas slides to another phase, like air that climbs a mountain and drops its rain on the far side. Heating is a sum of quiet engines. Ultraviolet photons knock electrons from dust grains and deposit energy into gas. Cosmic rays thread the disk and stir ions in dark interiors. Soft X-rays and shocks add warmth to thin plasma. Cooling answers through line radiation from atoms and molecules that shed energy efficiently. In cold regions, carbon and oxygen lines and molecular rotations carry away heat with precision. In warmer regions, hydrogen recombination and metal lines do the work. This ledger settles at a pressure that varies from center to rim, but remains smooth within any one neighborhood. The smoothness acts as a cushion that allows clouds to form without the disk tearing itself apart. Turbulence, always present, keeps ambition modest. Supersonic motions break clouds into structures with a fractal grace, producing a spectrum of eddies from giant flows down to knots where gravity can take hold. In this cascade, some regions compress, others rarefy, and a distribution of densities appears like a map of possibilities. Only the highest peaks of that distribution move quickly toward collapse. Everywhere else, turbulent pressure, magnetic tension, and shear create delay. The delay keeps star formation inefficient. A small percentage of gas becomes stars per freefall time, even in thriving disks. The rest waits for another push from a passing arm, a colliding shell, or the slow squeeze of a bar. Observations record the lifetimes of giant molecular clouds as brief, on the order of a few tens of millions of years. They assemble where flows converge, form clusters, and then disperse, either by internal feedback that shreds them or by shear that pulls them apart. The brevity matters. If clouds lived for hundreds of millions of years, they would hoard gas and convert it greedily. Instead, they recycle almost as soon as they bloom. Some of their gas recondenses into new clouds downstream. Some drifts into the diffuse medium and bides its time. The cycle closes without drama, and the disk keeps its face. Spiral arms and bars act as gentle weather fronts. They steepen local density and spark star formation by raising the chance that turbulence will bring densities above a critical level. In their wake, gas expands and cools, leaving lanes of older stars that fade to warm hues. The pattern repeats as the crest of the arm travels onward. and new gas flows into its region of compression. The same crest also aligns magnetic fields that guide material along preferred channels, keeping filaments parallel and delaying fragmentation where it would be wasteful. The result looks like a river network that reuses the same beds without digging new canyons at every storm. Shear provides another form of calm. The change in rotation speed with radius stretches structures before gravity can collect them into monoliths. A cloud that begins to grow feels its edges drift at different rates and becomes elongated. Elongation invites breakup into smaller pieces that either collapse or dissolve. On average, this keeps the disk thin and avoids the buildup of violent clumps that would heat the stellar population and thicken the plane. Measured rotation and measured dispersions combine into a stability parameter that sits close to unity over large areas. Near this value, order and fertility coexist. Below it, runaway collapse would follow. Above it, sterility would creep in. The disk works like a self-tuned instrument, not by intent, but by the interplay of processes that reinforce moderation. Feedback from young stars and dying giants turns isolated events into part of the climate. A single supernova drives a shock that cools and stalls, but a group of supernovae within a cluster creates a superbubble whose interior remains hot and buoyant. Such bubbles rise into the halo, venting energy that would otherwise overheat the plane. Their shells sweep up new clouds that may light later, extending influence beyond a single generation. At the same time, the porosity of the medium increases, allowing radiation and winds to find easy exits rather than pile up in one place. It is a style of weather that refuses to escalate. The more intense the local activity, the more vents open, and the more energy escapes into diffuse reservoirs. Dust serves as a quiet thermostat. Grains absorb starlight and re-radiate in the infrared, removing energy from sites where it is too concentrated and distributing it across wavelengths that slip from dense regions more easily. Grains also provide surfaces where molecules assemble, setting the pace of chemistry in cold cores. The abundance and size distribution of dust evolve with time as stars make new grains and shocks shatter old ones. Yet across wide ranges, dust tracks gas with a consistent ratio, ensuring that heating and cooling keep their familiar partnership. This consistency explains why galaxies with different histories still fall along similar relations between gas and star formation rate when averaged over kiloparsecs. High above the plane, a faint fog of extraplanar gas drifts in arcs and plumes. It carries the signatures of mixing layers where hot and cold meet, producing ions that live only in such borderlands. As it falls back in a rain of clouds, it brings with it the memory of past bursts and the metals they forged. The descent is not uniform. Some droplets evaporate, some condense others on their way down. The fountain blurs distinctions between inside and outside and smooths supply over time. Disks fed in this way avoid both sudden dryness and sudden floods. A power spectrum of structure in gas and dust reveals a nearly self-similar texture over orders of magnitude in scale. The slope of that spectrum tells how energy moves from large motions to small. The prevalence of that slope across many disks hints that driving and dissipation find common ground regardless of exact conditions. The universality stabilizes interpretation. A viewer can trust that the churning they do not resolve behaves like the churning they do resolve, allowing predictions that reach beyond immediate data. Chemical clocks add nuance to the forecast. Certain molecules assemble and survive only for specific durations under specific radiation fields. Their presence betrays age and environment. Ratios of ions in diffuse gas reveal how far cosmic rays penetrate and how evenly they are distributed. The answers cluster around values that suggest pervasiveness rather than patchiness. Even when star formation surges in a district, the influence spreads widely enough to prevent extremes from remaining local. The climate absorbs the spike and turns it into a kink that relaxes. Stellar populations record the average weather of their birthplaces. Velocity dispersions rise with age, as newborn stars inherit the agitation of their medium and then heat further through encounters with spirals and bars. The rise is predictable enough to be a chronometer. Metallicity distributions broaden as migration carries stars away from their natal radii. Even that broadening follows patterns set by the structure of the disk and its perturbations. The statistics of ages and metals become a retrospective map of wind patterns and seasons. All of these layers create a civility that resists accident. A dwarf galaxy falling through a halo may be stripped of gas, but the host's disk does not lose its composure. A minor merger may seed a ring or thicken a bar, but the global rate of star formation changes gradually. A cloud complex may flare and fade, yet the conversion of gas to stars over a whole arm keeps to a pace that can be predicted from its surface density and orbital time. If a single rule summarizes this poise, it is that time averages matter more than moments in determining appearance. The eye sees the average when it looks at a photograph taken over an exposure that spans an hour. The mind feels the average when it contemplates a galaxy whose history spans billions of years. Peace in this setting is not the lack of movement, it is the management of movement. Gravity pulls, turbulence softens, magnetism guides, radiation negotiates, and chemistry decides when to lock atoms into molecules and when to let them drift. Out of these negotiations emerges a disk that glows along lanes and fades toward rims with a grace so steady that it looks inevitable. The inevitability is earned each minute by countless small adjustments that seldom announce themselves. Some evenings, an observer can almost hear the climate breathe. A spiral pattern passes like a gentle front. A ring brightens and then dims. A bubble opens and a halo answers. The melody persists across these bar lines because the score is written in long phrases. The galaxy becomes a classroom where weather explains climate without contradiction. By morning, the numbers archived overnight will read like forecasts verified, and the photograph saved to a folder will show a face as calm as any on Earth, carved by wind and water that happen to be made of light and gas. Neighbors never stay entirely apart. Gravity carries introductions across voids, writes invitations in tides, and arranges meetings that last for orbits. A galaxy lives in this society with a poise that belies the frequency of encounters. The first approach is often a whisper. Outer halos touch before starlight feels a hand. Dark matter exchanges momentum through tides that operate at a distance, stretching one side and compressing another. The response is torque. Disks gain or lose angular momentum, bars are seeded, spirals brighten, and gas that was drifting finds a lane toward the center. No impact is required. A slow bow is enough to change the dance. As companions draw closer, longer filaments of stars begin to peel from their edges. These streams are delicate and pale, visible only when exposure goes deep. They trace the exact path of drawing and release. Loops curl behind dwarfs and arc across the halos of larger hosts like chalk lines left by a careful teacher. Each loop is a memory. It records not just position and speed, but also the mass of both partners and the shape of their invisible cradles. Over time, the stream thins and fades as stars spread along it. Yet the host remains. The disk settles. The image returns to symmetry, while the outskirts carry calligraphy written by a visitor who has already gone. Shells add another kind of script. An elliptical with smooth light may wear faint ripples that form concentric arcs. They arise when a small companion is taken in along a nearly radial path. Its stars wrap around the center and pause at apocenter, piling briefly to increase surface brightness before moving on. Several wraps produce several shells, each slightly offset, each marking a time when the stars turned back. This process has a calm cadence. It is not an explosion. It is phase wrapping in a potential that holds still while the debris learns its new routes. Dynamical friction carries larger bodies inward when they share a common sea of stars and dark matter. As a satellite plows through this sea, it leaves a wake that tugs backward and drains orbital energy. The result is a slow spiral toward the center. Stars from the companion shear into streams before the core arrives. Gas shocks and flows inward more quickly, feeding central rings or quick starbursts that soon pass. When the central remnant finally reaches the heart, it can form a compact, kinematically distinct core whose rotation differs from the surrounding bulge. The odd spin does not disrupt the visible calm. It hides like a whisper beneath a choir. Not every encounter ends in unity. Many are flybys that do their work at safe distance. A pass can tilt a disk, induce a warp, or rearrange outer gas without tearing the plane. Tides can ignite star formation by causing clouds to converge, then leave a galaxy to resume its average pace. A bar born during such a visit may persist long after the visitor has moved on, continuing to guide gas for many rotations. In this way, neighbors act as catalysts. They are present at the origin of order and then depart, leaving the reaction to proceed on its own. Group life introduces gentle harassment. Multiple low-mass companions tug at different times and directions, thickening the disk slightly and seeding flares that lift the outer parts. In such places, ram pressure from a thin bath of intragroup gas helps clear the very edge of diffuse material. The effect is sculpting rather than scouring. Spirals keep their lanes, bars keep their rhythm, but the outskirts look trimmed, the star-forming rim stepped inward by a small amount. The change is modest and the face remains friendly. In clusters, the same pressures become bolder. Galaxies rush through a dense medium and feel wind on scales measured in tens of kiloparsecs. Gas in the disk is pushed back and stripped in arcs that trail away like banners. The core of the disk may still form stars for a while, drawing from gas that lies deep in the potential. Over time, even that reservoir thins, and the galaxy reddens into a lenticular with a smooth, almost glass-like profile. The result is not chaos, but an ordered quenching. The disk remains thin, the bulge stands calm, and the bar, if one existed, may soften. Where stripping is partial, narrow tails glow with new clusters born in compressed gas. They glimmer like beads on a string before the string dissolves. Mergers of equals write a different ending. When two stellar cities with similar mass fall together, their disks scramble during close passages and finally coalesce. Stars exchange energy through the changing potential, a process called violent relaxation that moves them onto new orbits that forget their origins. The final shape glows like a soft ellipse with little trace of spiral geometry. Out of nearby confusion comes a smooth light profile that calms the eye as surely as any grand design. If gas was plentiful, the union may have kindled a blaze that quickly consumed the reservoir and then shut down when feedback lifted the pressure beyond the point where collapse could continue. If gas was scarce, the joining remained dry, and the result was quiet from the start. Between extremes lies the quiet merger. A large host takes in a small companion along an orbit that skims the plane. The stellar disk feels a passing shiver, and then heals. The companion loses its gas and gives its stars to the host's outskirts, where they thicken the edge and add a faint halo. Globular clusters carried in, along with them, settle into new orbits, adding to a system that remembers a history of acquisition without shouting it. The central parts remain nearly unchanged. The bar, if present, may gain or lose strength slightly. Rings may brighten where new material meets existing resonances. The signature is subtle, and the serenity returns in less than 1 billion years. Tidal dwarfs appear along the ends of spectacular tails when mergers fling gas into long arcs that fold back. In places where the flow stalls, gravity can collect material into small island galaxies that carry little dark matter of their own, being built from the luminous debris of their parents. Some persist and become obedient satellites, others fall back. Their presence proves that encounters can create as well as destroy, and that the recycling of material continues at every scale. The scene is dramatic, yet the outcome seconds, the theme of restoration. The hosts merge and smooth. The dwarfs either join the family or fade. Angular momentum is the quiet prize traded during these meetings. Disks lose some to their halos while gaining mass at small radii. Bars transfer angular momentum outward through gravitational torques, feeding bulges that puff gently rather than crash. Gas that once sat at wide orbits moves inward and forms stars in lanes, then returns momentum to the halo through winds and fountains. The exchange is not reckless. It leans toward equalization. The result across epochs is a drift toward profiles and rotation curves that repeat within families of mass. The exact episode by which a galaxy arrived matters less than the tendency of many episodes to converge on the same gentle slope of light. Kinematic heating from passages spreads the velocities of stars, thickening the disk and lifting older populations above the plane. This heating is not severe in small encounters. The result is a layered structure where young, thin components ride inside older, thicker ones. Each layer has its own scale height and its own memory of agitation. Viewed edge-on, dust slices the midplane, and warm light bulges above and below it with a softness that invites long staring. The coexistence of layers creates depth without disorder. Some encounters deliver gas that orbits in a different plane. The host responds by building a polar ring, a wide circle that rises at right angles to the main disk, bright with young stars that trace a compass in light. The stability of such rings surprises at first, yet their orbits can be long-lived when embedded in halos whose shapes provide a restoring force. They add serenity through geometry, making the galaxy look like a sculptor's demonstration of balance. When the ring eventually dissolves through torques and star formation, it leaves a faint shell and a memory of a time when the host wore an emblem in the sky. Across cosmological time, these processes average into growth that is steady rather than desperate. Most of a galaxy's mass accumulates through smooth inflow and many small additions. Major collisions are rare enough that between them disks can rebuild or maintain order. Tides remodel rather than ruin. Streams drape without choking. Bulges rise not as cliffs but as long hills. Deep images confirm this narrative by showing that a vast fraction of seemingly isolated galaxies carry faint halos of debris while remaining composed at their centers. History wraps them in lace while the face stays calm. In simulations that trace millions of particles, the quiet of the final picture comes from steps that undo as well as do. When a companion tilts a disk, the warp precesses and often dies away in a few giga-years. When a bar strengthens under a tide, it later weakens as central mass builds. When a ring brightens where orbits meet, it fades as gas is consumed. The stars keep counseling patience. Their orbits fill available phase space with grace, spreading evenly until no sharp gradients remain. This is mixing, not in a kitchen but in a halo where time is the spoon. An observer might stand beneath a clear night and think of neighbors as threats. The numbers suggest another story. Encounters are many, yet catastrophe is rare. Influence is frequent, yet the appearance of rest survives. The sky is a collage made of meetings, and the most common outcome of a meeting is not wreckage but adjustment. A galaxy accepts a pull, gives a little of its spin, takes a little mass, tightens a ring, tilts a plane, and then continues as if it had practiced such compromises for eons. The relaxation that follows is not denial. It is the return to form that many small nudges permit. This is why a photograph can show peace, even in a universe built by assembly. The calm on the screen is not ignorance of neighbors. It is a portrait of society at scale, where gravity is the etiquette and orbits are the habits that keep conversations civil. Tides speak softly. Mergers end in sculpture rather than debris. Streams write histories in ink so pale that only patient eyes can read them. The centers stay composed while the edges do the talking. The lesson is that serenity grows stronger, not weaker, in a crowd that knows how to share the pull. Sight narrows when it trusts only to human eyes. A galaxy that looks like a calm scroll of starlight hides laboratories that glow in colors the retina cannot read. Switch bands, and the same shape becomes a different manuscript. Radio waves outline fuel, infrared warms the page with dust, ultraviolet sketches recent births, X-rays reveal shock and pressure, gamma rays hint at particles that refuse rest. The surprise is not variety. The surprise is consistency. Each band enlarges the same theme of balance, as if many instruments were playing one melody in different keys. At long radio wavelengths, neutral hydrogen speaks with a single line that passes through dust. Maps of this line show gas that stretches beyond the starlight, a cool ocean lapping at the shores of the disk. The contours are rarely ragged. Instead, they curve with a patience that suggests stable orbits and a halo that steadies them. Warp and flare appear at the edge, yet symmetry persists around a gentle midline. In the same band, a smoother glow emerges from electrons spiraling in magnetic fields. This synchrotron light tracks the recent history of massive stars that ended in supernovae, and it does so with a calm proportionality to far-infrared dust emission. The far-infrared radio correlation, tight across wildly different systems, behaves like a signature of regulated energy flow. Star formation rises, radio and infrared rise together, and the rule holds with a fidelity that reassures. Shift to millimeter and submillimeter light, and the view dives into the cold lungs of the disk. Carbon monoxide traces molecular reservoirs, denser lines such as HCN and HCO+ pick out the most compressed pockets, and fine structure lines like C2 at 158 microns carry away heat from photodissociation regions where ultraviolet grazes the edges of clouds. The ratios of these lines function as thermometers and barometers. They speak to pressure, density, and the hardness of the radiation field. When graphed across radii, the patterns slope softly rather than jag upward and down. Rings where orbits meet show enhanced, dense gas fractions, yet even there the efficiencies follow curves rather than cliffs. The message is that cooling and heating have agreed on truce lines that wander but do not break. Infrared continuum brightens where dust grains drink starlight and glow. Shorter infrared bands favor warm grains near clusters. Longer bands favor colder dust threaded through the disk. Fit the full curve with radiative transfer models, and the total energy that stars pour into dust emerges with modest uncertainties. Compare that energy to what escapes as unreddened starlight, and the ledger balances within a factor that declines with stellar mass and metallicity in a way that can be predicted. The dust becomes an accountant, impartial and thorough, recording how light was processed rather than lost. Even in luminous starbursts where extinction is heavy, the accounting closes. Hidden order becomes not a metaphor, but a literal budget. Ultraviolet light is a diary kept in brisk handwriting. It fades quickly from populations older than 100 million years, which makes it a near real-time tracer of young clusters on galactic timescales. Smooth ultraviolet arcs along arms show where the crest of compression recently passed. Gaps mark older passages. Corrected for dust by using infrared as a counterweight, ultraviolet flux gives star formation rates that agree with rates estimated from hydrogen recombination lines and from radio-free free emission. Methods that should have disagreed in the presence of patchy extinction converge when the full spectrum is used. That convergence is an emblem of order, a sign that the machine is legible from several angles. Optical and near-infrared spectroscopy add the voices of ions and atoms. Ratios of collisionally excited lines measure metallicity and ionization parameter, while recombination lines count the photons of hot stars. Integral field maps spread those diagnostics across faces of galaxies, revealing gradients that decline outward, but do so without jagged breaks, except where bars have stirred. Where shocks from outflows breathe on the gas, line widths broaden and certain ratios rise in a way that flags mechanical input. Yet even these signatures arrange themselves along cones and shells with bilateral symmetry that seems drawn with a ruler. The violence organizes, then subsides, and the disk resumes its lines of calm emission. X-rays open the furnace doors without ash. Soft emission reveals hot plasma in superbubbles and halos. Harder emission picks out populations of X-ray binaries, compact remnants accreting from companions, whose numbers scale with star formation rate or with stellar mass depending on type. Count them, and a second estimate of star formation or accumulated history appears, an independent audit that tends to agree with ultraviolet and infrared ledgers. In group and cluster environments, X-rays display cavities where jets pushed the hot medium aside. Ripples spread outward in weak shocks, evenly spaced like rings from a stone dropped in a lake. The power required to maintain those patterns is close to what is needed to offset cooling. This closeness recurs enough to feel intentional, though it arises from feedback loops that only need thresholds and delays, not foresight. Gamma rays are rarer, but they speak to the highest energies carried by cosmic rays. Where star formation is vigorous, hadronic interactions between cosmic rays and gas produce a glow that correlates with other traces of recent activity. The correlation is not as tight as in radio and infrared, yet it is coherent enough to extend the same story into a band where randomness might have been expected. Particles accelerated in shocks do not wander aimlessly. They fill volumes set by field geometry and gas density, and their emissivity reflects a balance between injection and escape that mirrors the balances seen in other bands. Polarization across wavelengths provides texture to structure. Submillimeter polarization traces dust grains aligned by radiative torques, revealing field orientation in dense environments. Radio polarization beyond the disk measures fields in halos. Faraday rotation maps line-of-sight components, and optical polarization from scattered light near active nuclei sketches bicone shapes, otherwise invisible. These measurements confirm that the paths of least resistance for gas and photons align with the drawn lanes. Magnetized corridors carry outflows. Dusty curtains hide or reveal cores depending on viewpoint. Geometry repeats across scales, from cloud filaments to kiloparsec cones, as if a favored blueprint were being reused. Spectral energy distributions tie this panorama together, a single model that includes starlight, dust attenuation, dust emission, gas lines, and non-thermal components can be fit to multiband data. When the fit is honest about uncertainties, it returns star formation histories, stellar masses, dust masses, and ionization parameters that agree with independent estimates within stated errors. The agreement is never perfect, yet it is robust enough to turn invisible light into intuition. A face that once seemed like a flat photograph becomes a system of flows and stores, of inputs and outputs, all linked by constraints that keep errors from exploding. Time adds a final layer of calm. Changes in different bands arrive with expected delays. A rise in ultraviolet appears before a rise in far infrared as dust warms. A cluster that fades in ultraviolet leaves a trail in near infrared. A brightening in radiosynchrotron waits for massive stars to end, then lifts and decays as electrons age. X-ray binaries respond on timescales set by binary evolution, slower and more drawn out. These staggered responses act like the movement of sections in an orchestra, woodwinds entering before brass, percussion reminding the ear of an earlier theme. The predictability of the sequence turns complexity into narrative. There are corners where anomalies live, compact dwarfs with extreme radiation fields, giant disks with surprisingly faint halos, low surface brightness galaxies with dust that glows colder than expected. Even in such cases, multi-wavelength study pulls threads into pattern. The dwarf's hard spectrum is explained by scant dust and hot stars that leak ionizing photons. The faint halo hides because the magnetic field has slid into vertical modes that lower planar synchrotron. The cold dust glows where metallicity is low and grains are large, coupled weakly to starlight. Oddity is not a defeat. It is a reminder that rules are descriptive, not prescriptive, and that exceptions often arrive with their own order once the right band is chosen. To look with all these eyes at once is to sense a unity that no single image can offer. Gas outlines a scaffold, dust carries the radiative burden, stars illuminate, fields guide, hot plasma ventilates, and high-energy particles whisper about the last steps of massive lives. The lines, arcs, and rings that the visible picture provides are not illusions. They are the bright edge of a spectrum-wide design. Calm is credible because the unseen bands, noisy in principle, end up coherent in practice. They keep pace with one another through physics that favors balance over extremes. A final glance returns to the visible, now enriched by what the invisible has said. The arms look gentler when one knows they host dense gas cued by millimeter lines and dust heat that glows far beyond sight. The bar seems more purposeful when radio polarization shows fields steering gas to a ring. The halo's faintness feels more like air than emptiness when X-rays draw bubbles that slowly rise. The photograph has not changed, but its meaning has, and the meaning is restful. The universe does not whisper only to human eyes. It sings across the spectrum, and the song is a measured one. Time is not a clock tick in a galaxy. It is a tide that alters shorelines so slowly that only patient measures reveal the change. The face that seems fixed in a photograph is made by processes that move at the pace of seasons written in billions of years. Light profiles swell gently, colors drift from blue to gold, arms sharpen then soften, bars strengthen then relax, rings brighten then fade. No single moment tells the story. Only accumulation does. Gas arrives first as a quiet rain from filaments that feed the halo. Some droplets fall straight to the disk. Others join a hot atmosphere and wait for cooling times to shorten. When the supply is generous, the disk grows inside a cradle that spreads outward. New stars prefer the outskirts where fresh gas lands, and the radius that encloses most of the light creeps larger with age. The pattern is inside to outside in starlight and outside to inside in fuel. Observers see this as a mild blue rim around a warmer core and call it youth on the edges. The growth is not dramatic. It is a long knitting of faint material into a wide scarf. Bars feel time through torque. They transfer angular momentum outward and slow, which moves their corrotation radius farther from the center. As corrotation drifts, the places where orbits change, families migrate, and rings adjust their seats accordingly. The bar may trap stars into vertical resonances and puff into a shallow box, changing the bulge without a collision. In some histories, the bar weakens as central mass accumulates, then reappears after fresh gas regrows a responsive disk. The cycle is unhurried and soft. A shape that looked like a permanent statement is revealed as a phrase in a long paragraph. Radial migration sifts the disk like a patient gardener moving stones along a path. Stars near corrotation with a spiral pattern can shift their guiding centers inward or outward without heating their orbits, a trick that changes a star's address while leaving its chill unchanged. Over billions of years, this diffusion blurs the link between age and radius and softens metallicity gradients. The record that once looked like a ledger of rings becomes a watercolor with careful blends. Peace does not mean stasis. It means the sum of many small shuffles that never raise a voice. Quenching arrives in several costumes that all reduce the supply of new stars. In massive halos, gas falling from the cosmic web can be shocked to temperatures where it cools only slowly. A hot cloak forms around the galaxy, and the tap of cold inflow turns from a stream to a drip. In dense environments, ram pressure strips the outskirts and tides steal what clings, a quiet bank account drained by fees rather than by a single bill. Feedback from a central engine provides maintenance heat that keeps the cloak buoyant. The pace slackens first at the outer rim, then marches inward, a pattern some call outside in quenching. Colors warm, nebula lines fade, and the main sequence of star formation, the familiar relation between stellar mass and birth rate, loses one participant without drama. Another road to rest is structural. A compact bulge raises orbital speeds and stabilizes the inner disk against collapse, even in the presence of gas. This is sometimes called morphological quenching. Gas drops in, but shear and high dispersion prevent it from making many new clusters. The city acquires quiet zoning laws. Stars still form where pressure can climb, perhaps in a ring at a resonance, but the rate is low and steady. Over time, the spectral signatures shift toward older populations. The face looks more polished than youthful, yet the hand that polished it was gravity taking a more concentrated form. Not all stops are permanent. Rejuvenation can arrive as a faint ring of blue woven into a red body, when small inflows or captured streams ignite star formation in a circle where orbits slow. Weak bars or oval distortions channel modest supplies toward the center and revive a necklace that glows for several 100 million years. The event is not a return to youthful global vigor. It is a graceful coda that adds fresh chords to a finished theme. The galaxy glows slightly cooler, then returns to its warmer tone when the supply fades. Stellar evolution ensures a slow river of recycled gas flows even from populations that no longer form many stars. Evolved giants shed envelopes, supernovae of long gestation seed, the medium with iron, and planetary nebulae lift shells into the thin air. The amount is modest, yet in galaxies with little external supply, it becomes a notable fraction of what future stars will use. Chemistry shifts in step. Iron rises relative to alpha elements that were forged in quicker deaths. Spectra display this drift in line ratios that function like clocks. The clocks rarely alarm. They hum at a rate that confirms the passage from fast birth to measured maintenance. Disks settle with age. Stellar velocity dispersions climb as orbits feel many small kicks from spirals, bars, and transient perturbations, and as the stars inherit the agitation of their gas at birth. With higher dispersions, scale heights increase and layers stratify. A thin component filled with the young rides within a thicker, warmer sheath of the old. Seen edge on, the midplane carries a narrow vein of dust that dims toward the center as reservoirs decrease, while soft light swells above and below with the patience of time. The layering is not a scar. It is a memory kept in height. Beyond individual galaxies lies the slow contraction of the universe's star-making fervor. Long ago, gas was abundant and disturbed, and the average birth rate per unit mass higher. As time moved forward, the general supply dwindled, the pace softened, and the characteristic brightness of star-forming systems dimmed. This history writes itself in surveys as a curve that rises, peaks, and declines, a grand weather report for the cosmos. Individual galaxies follow their local stories within this climate, yet the climate matters. Moderation today is not only a personal choice, it is the tone of the era. Rings also teach patience. Inner rings at resonances may persist for giga-years, forming stars at a pace set by orbit crowding and by supply along bar lanes. Outer rings form where material piles near slower resonances, then fade as gas is consumed, or as the pattern speed changes and the resonance moves away. Pseudorings, partial arcs that nearly close, fill their gaps over time as flows and ages align. The modest morphing of these features makes them gentle clocks. A ring's color, sharpness, and size speak of a few billion years of history with a vocabulary that does not raise its voice. Faint outskirts hold a final lesson. The very edge of a disk is a frontier where densities hover near thresholds. There, the passage of a small satellite or the breathing of a warp can make the difference between a blue scallop of new clusters and a quiet grey continuation of old stars. Over time, such scallops appear, fade, and are replaced a little farther out. The truncation radius, where the optical disk seems to end, is not a cliff. It is a shelf that advances slowly, a sign that building continues at a pace the eye could miss without guidance. Even the halo of dark matter evolves in a way that reflects the slow hand. Early rapid accretion gives way to gentle growth. The contraction caused by infalling baryons may later soften as feedback pumps energy back into the inner regions. The circular velocities of stars and gas keep their flat dignity while the inner profile adjusts. The stability felt by the visible disk owes much to this placid backdrop. Change occurs, yet it is distributed broadly and arrives with the discretion of a host who will not startle a guest. Calendars for galaxies use units unfamiliar on Earth. Orbital times near the Sun's radius in a large spiral are a few 100 million years. Bars change their beat over several billion, gradients soften over 10 billion, and hot halos remember events for intervals longer than human ancestry. Measured this way, a photograph is an instant, a spectroscopic survey is an hour, a lifetime of observatories is a season. With each season, patterns that were suspected become obvious, and features that seemed permanent reveal themselves as phases. The patient hand is not separate from physics, it is physics writ long. Conservation of angular momentum keeps disks thin even as they are stirred. Thermodynamics favors negative feedbacks that limit extremes. Orbital resonances that look decorative become the gears that turn rings and bars in concert. Gravity respects adiabatic invariance when changes are slow, allowing stars to adjust their paths without shock. These phrases sound technical, yet they describe kindness. Slow change lets structure persist while parameters drift. A calm galaxy is therefore the product of many long agreements. Supply tapers without vanishing. Structure evolves without collapsing. Feedback answers without shouting. Migration blurs without erasing. Quenching pauses without forbidding renewal. When people say that galaxies are old, they name more than age. They name the quality of age well kept. A maturity that holds beauty not despite time, but because of it. A final image on a screen carries that quality. It is a portrait of patience in matter and light, a reminder that serenity can be the outcome of evolution, not a refuge from it. He studies an image of a spiral and realizes the calm he feels comes partly from him. The mind prefers gradients to abrupt edges, prefers curves that guide rather than corners that jab, prefers repetition with small variations to noise without pattern. A galaxy offers all three: a gentle decline of light, a patient arc, a motif that returns with new phrasing. The relief he senses is not an escape from truth, it is resonance between a brain tuned by evolution to detect order and a cosmos that builds it from simple laws extended over immense time. He notices another layer. The scale of a galaxy is too grand to threaten. Storms inside it cannot touch a cheek on Earth. Radiation that could sear is thinned by distance into an image that warms without burn. Safety is part of the serenity. a safe seat far from the stage where an opera of gravity and light proceeds at a tempo slower than worry. The mind can watch without bracing, can wonder without guarding, can accept the drama as beauty because its consequences do not cross the gulf. He listens to language and hears how metaphors that soothe on earth appear in descriptions of galaxies: arms, bars, rings, halos, fountains, gardens, climate. None are literal, all are useful, and they carry the comfort of familiarity. He suspects that the vocabulary is a bridge for emotion, a way to invite human calm into cosmic fact. Yet the bridge is not deceit. The underlying maps and numbers hold without the metaphor. The mind simply finds it easier to rest when ideas wear familiar clothes. He reflects on time and sees why a photograph calms. An exposure averages moments into a surface that looks untroubled, a process echoed by perception, which averages countless instants into a sense of continuity. A galaxy is itself an averaging machine, turning short storms into long seasons. The consonance between image, mind, and subject multiplies the effect. He recognizes that this is not mere sentiment. It is a clue to how understanding works when scales are enormous and patience is mandatory. He thinks of listening rather than seeing. If the rotation of a disc could be turned into sound, the pitch would be too low for human ears. If the growth of a bar could be rendered as rhythm, the beat would be a drum strike every billion years. We are not born to that time scale, yet the imagination can slow itself and pretend to hear. In that pretense, anxiety fades, because the drum of a life is quick by comparison, and worry needs quick beats to flourish. The galaxy becomes an instrument for loosening hurry. He considers the puzzle of significance. The stars in a disk do not care what he feels. The laws that guide them do not intend to soothe, yet he is soothed. Is that comfort legitimate? He decides that it is, not because the galaxy offers reassurance on purpose, but because alignment between structure and perception is a real fact. The universe is not obliged to be hostile to minds. It is allowed to contain arrangements that we find restful, and our rest can still be honest science if we use it as a doorway rather than an endpoint. Calm does not cancel rigor. It can support it by keeping attention steady. He pictures the invisible strands of community that connect human lives and compares them with the lanes and flows in a galaxy. Both are networks where traffic must be guided to avoid congestion and collapse. Both develop habits, feedbacks, and thresholds. Both flourish when push and pull find a middle path. He does not force the analogy. He lets it sit as a gentle suggestion that coherence at one scale can inspire coherence at another. The cosmic city does not teach morality, yet it models sustainability without sermon. He recalls night walks in a town where streetlights were few. The sky was a commons that belonged to everyone who looked up. A galaxy is a shared object in that way, not owned by any observer, not reduced to any one photograph. It can be carried in memory as a shared rest. He imagines a future child seeing the same spiral through better instruments and feeling the same slowing of breath. Continuity across generations, across instruments, across languages, becomes part of the quiet. The galaxy is durable enough to support this chain. Its beauty is portable across time. He lets speculation visit. If life had evolved in a universe without galaxies, would minds exist with the same love of pattern? Perhaps, perhaps not. He cannot know. He only knows the world, that is, where gravity gathers matter into disks and ovals that endure, where light takes long roads to reach retinas and sensors, where attention can dwell on shapes that earn their survival by balancing forces. In such a world, peace is not an accident. It is a product of patience, and patience is the currency of understanding. He attends to small kindnesses inside the large scene. Dust that would blind becomes a palette for infrared colors that inform rather than obscure. Jets that could ruin instead ventilate. Shocks that could shred instead seed. He is not naive. Disruption exists, and eruptions do happen. Yet the prevailing mood at the scale of a galaxy is measured, and that mood matters when one seeks rest. He never mistakes the face for the whole, but he allows the face to do its work, to steady him while he studies the interior with sharper tools. He thinks about the cost of calm and pays it willingly. The cost is attention. To be soothed by a galaxy, one must look long enough for the pattern to rise from faintness, must read a caption or two, must accept that beauty may come with equations attached. This is a small price for reliable consolation. The payoff is a counterweight to daily alarms, a reminder that the world includes processes that are indifferent to the day's noise and faithful to their own pace. He imagines sending a postcard from a distant arm to his own brief life. It would read simply, "All is in motion, all is in balance, continue." No promise of rescue, no assurance of personal fate, just a statement that structure persists where it can, and that this persistence is available to anyone who looks. He smiles at the thought that such a message would be enough on some days. He stands and dims the room. The final impression is detail within quiet, quiet within vastness, vastness that does not overwhelm because it is arranged with grace. He knows that mystery remains, that theories change, that new instruments will find new tensions beneath the surface. The existence of further depth does not make the surface less soothing. It makes the calm more earned because it survives scrutiny. He leaves the image on the screen, unchanged, a spiral that would look right on the day the first telescope was built and on the day the last telescope retires. He carries it from the desk to the next hour, like a slow metronome that refuses to rush. If someone asks what he learned, he will say that galaxies are a form of patience, a way the universe shows that motion and rest can share the same room. He will say that the most relaxing facts are not escapes from complexity. They are the moments when complexity arranges itself into a pattern the heart can live with. Night presses gently against the window, and the room surrenders its angles to shadow. The screen still holds a whirl of light, a careful curve that could be breath slowed into geometry. He does not search for more. He lets the shape do what shapes can do when given time. It steadies the hour. Gravity writes in a hand that never hurries, and the ink is starlight, softened by distance. Arms lift from a core like thoughts, circling a quiet certainty. Dust lays its soft veil, not to conceal, but to teach how to look by asking the eye to linger. In the spaces between knots, darkness rests, not as absence, but as canvas. Somewhere, stars are being born in rooms of pressure and whisper, and somewhere else, old stars are cooling with elegance. A ring counts its steps, a bar turns with a patience that would shame clocks. All of it proceeds without witness, yet a mind witnessing becomes calmer for knowing it does. The comfort is not possession, it is alignment. He closes his eyes and finds the same curve inside them, a memory of order that does not depend on sight. The day will return with its errands and its minor tempests. The sky will remain, large and unworried. He will carry the idea of a disk that keeps its line, of a core that breathes without haste, of a halo that holds the stage. If peace is a verb, then the universe is conjugating it tonight, softly, at scales that make fear look small. The page of the sky turns, not to end a chapter, but to continue a rhythm older than speech. He listens to that rhythm and lets it choose his pulse. The lights dim, the curve remains, and the room becomes a little larger than itself. End of script. Sweet dreams.